Picture a world where silence reigns supreme, broken only by the groaning of glaciers and the whisper of wind across endless white expanses. Imagine standing at the edge of what was once a verdant valley, now buried beneath ice sheets 2 miles thick. The air cuts through your lungs like crystalline daggers, and the horizon stretches into an infinite canvas of blue-white desolation. This was Earth 20,000 years ago, a planet transformed into something almost alien. Massive ice sheets stretched from the Arctic down to what we now call New York and London. The oceans had retreated, their waters locked away in frozen monuments that scraped the sky. Woolly mammoths wandered across frozen grasslands where palm trees once swayed, their breath-forming clouds in air so cold it could shatter steel. The landscape tells a story of dramatic transformation. Where the Mediterranean Sea sparkled, a narrow channel barely connected the Atlantic to a much smaller body of water. Britain was not an island but a peninsula, connected to continental Europe by a bridge of frozen earth. The coastlines we know today lay buried beneath hundreds of feet of ice, and the sea level had dropped by over 400 feet. In this frozen realm, the aurora borealis danced across skies that seemed closer to Earth, painting the ice in ethereal greens and blues. The moon appeared larger in the crystal-clear atmosphere, casting shadows that stretched for miles across the unmarked snow. It was a world of profound beauty and terrible isolation, a planet that seemed to hold its breath, waiting for something to change. The creatures that survived this transformation were remarkable adaptations of life's persistence. Cave bears huddled in limestone caverns, their massive forms generating enough warmth to melt small patches of ice around their dens. Saber-toothed cats prowled the edges of forests that clung to life in protected valleys. And somewhere in this vast wilderness, small bands of humans gathered around fires, their faces illuminated by flames that represented their only defense against a world that seemed determined to freeze them from existence. But here lies the question that haunts us across millennia. Was this frozen world simply the result of natural forces, orbital mechanics, and volcanic ash, and the slow dance of climate systems? Or was something else at work? Something deliberate? Something engineered? The ice holds secrets that we are only beginning to understand. Within its crystalline structure lie layers of history, chemical signatures, and anomalies that challenge our understanding of how worlds freeze and thaw. As we drill deeper into these ancient archives, we discover evidence of sudden temperature drops, of atmospheric compositions that don't quite fit the natural models, of events that occurred with a swiftness that seems almost impossible. The conventional wisdom speaks of gradual cooling, of ice sheets that advanced slowly over thousands of years. But the evidence whispers of something else, of changes so rapid they caught entire ecosystems off guard, of freezing events so sudden that mammoths died with spring flowers still in their mouths. What if the Ice Age was not nature's slow descent into winter, but technology's swift hand altering the very breath of our planet? As the ice-locked world held Earth in its crystalline grip, mainstream science offers us a story rooted in the predictable dance of celestial mechanics. The conventional narrative unfolds like a cosmic clockwork, where orbital cycles become the primary conductor of our planet's climate symphony. The Milankovitch cycles, named after the Serbian mathematician who decoded their patterns, reveal how Earth's relationship with the Sun shifts across vast timescales. Picture our planet as a spinning top, wobbling slightly as it traces its elliptical path around the Sun. Every 100,000 years, the orbit stretches from nearly circular to more pronounced ellipse. Every 41,000 years, the tilt of Earth's axis shifts between 22.1 and 24.5 degrees. And every 26,000 years, the axis itself wobbles like a cosmic compass seeking true north. These orbital variations change the distribution of solar energy reaching Earth's surface. When northern hemisphere summers receive less intense sunlight, winter snows fail to melt completely. Year after year, the accumulated ice grows thicker, reflecting more sunlight back to space and creating a feedback loop that plunges entire continents into frozen slumber. The geological record supports this narrative with meticulous detail. Ice core samples from Greenland and Antarctica reveal the chemical signature of ancient atmospheres, showing how carbon dioxide levels dropped to barely 180 parts per million during glacial maximums, nearly half of pre-industrial levels. Ocean sediment cores tell complementary stories. They're microscopic fossils revealing how sea temperatures plummeted and currents shifted their ancient patterns. Volcanic activity adds another layer to this natural symphony. Massive eruptions inject sulfur dioxide into the stratosphere, creating reflective veils that can cool the planet for years or even decades. The Toba supervolcano, erupting 74,000 years ago, may have pushed humanity to the brink of extinction as ash clouds blocked sunlight across entire continents. Ocean currents play their part as massive conveyor belts of heat distribution. The thermaline circulation, driven by differences in water temperature and salinity, carries warm tropical waters northward, while cold polar waters sink and flow toward the equator. When these currents weaken or redirect, entire regions can experience dramatic cooling within decades. The ice sheets themselves become active participants in their own growth. As they expand, their brilliant white surfaces reflect up to 90% of incoming solar radiation back to space, compared to only 10% reflection from dark ocean water or forest canopy. This albedo effect accelerates cooling in a self-reinforcing spiral that can lock entire hemispheres in ice for millennia. Continental drift contributes its own slow-motion influence. The positioning of continents affects ocean circulation patterns and atmospheric flow. When Antarctica drifted over the South Pole approximately 35 million years ago, it enabled the formation of the massive ice sheet that persists today. Similarly, the closing of the Panama Isthmus around 3 million years ago redirected ocean currents and may have triggered the intensification of northern hemisphere glaciation. Atmospheric dust from meteoric sources adds microscopic complexity to the climate equation. Cosmic dust, settling constantly but imperceptibly, can accumulate over thousands of years to subtly alter atmospheric opacity. During periods of increased cosmic ray activity, cloud formation patterns may shift, influencing regional precipitation and temperature. The carbon cycle operates as Earth's thermostat, with ice ages representing periods when the planet's carbon storage system's oceans, forests, and soils locked away more CO2 than they released. Falling sea levels exposed vast areas of continental shelf, reducing the ocean's capacity to absorb atmospheric carbon. Meanwhile, expanding ice sheets buried carbon-rich soils and reduced forest cover, further decreasing the planet's ability to recycle atmospheric gases. Yet even as this conventional narrative provides elegant explanations for the general patterns of glaciation, anomalies persist in the geological record. Sudden warming and cooling events that seem too rapid for orbital mechanics. Chemical signatures that don't quite match the expected patterns. Ice core layers that tell stories of atmospheric compositions that challenge our models. The science is robust, the evidence compelling, and mathematical models increasingly sophisticated. But as we prepare to venture beyond the boundaries of accepted explanation, these very foundations of understanding become the backdrop against which more mysterious possibilities emerge. But what if the cosmic clockwork of orbital mechanics tells only part of the story? What if hidden beneath the elegant mathematics of Milankovitch cycles lies a deeper mystery, one that challenges our most fundamental assumptions about the natural order of climate change? The possibility emerges, like a shadow cast by flickering firelight, that Earth, as descent into the Ice Age, was not entirely natural, but engineered by forces whose sophistication exceeded anything we attribute to our ancient ancestors. This speculation requires us to reimagine the very nature of technological advancement and to consider that intelligence capable of planetary Climate manipulation may have existed long before recorded history. Consider the precision required to orchestrate such a transformation. Cooling a planet is not simply a matter of blocking sunlight or redirecting ocean currents. It demands an understanding of atmospheric chemistry, oceanic circulation, albedo effects, and feedback loops that rivals our most advanced climate models. It requires the ability to trigger cascading effects that could maintain themselves across millennia without constant intervention. The whispers of artificial winter echo through anomalies that conventional science struggles to explain. Why did the Ice Age begin so suddenly in certain regions? Why do some glacial advances show signs of geometric precision in their boundaries? Why do certain ice core samples contain chemical signatures that seem to appear and disappear with almost technological regularity? Modern geoengineering research provides a framework for understanding how such manipulation might be possible. We now know that relatively small interventions in atmospheric composition can trigger massive climate shifts. Injecting sulfur particles into the stratosphere, seeding clouds with reflective materials, or altering ocean surface chemistry could theoretically plunge regions into prolonged cooling. If we can conceive of such technologies today, what might a more advanced civilization have achieved? The concept of atmospheric engineering takes on new dimensions when viewed through the lens of advanced materials science. Imagine programmable aerosols that could self-regulate their reflective properties based on solar input. Picture crystalline structures that could remain suspended in the stratosphere for decades, creating a semi-permanent solar filter. Consider the possibility of atmospheric catalysts that could alter the fundamental chemistry of weather systems. Ocean manipulation offers another avenue for planetary cooling. Advanced understanding of fluid dynamics could enable the redirection of major currents through precisely placed barriers or temperature differentials. The creation of artificial upwelling zones could bring deep, cold water to the surface, while the strategic modification of salinity levels could disrupt the thermaline circulation that distributes heat globally. Even more speculative possibilities emerge when we consider energy systems beyond our current comprehension. What if an advanced civilization possessed the ability to influence solar radiation directly, not through atmospheric filters, but by manipulating electromagnetic fields in space? Could they have created artificial variations in Earth as magnetic field that affected how cosmic radiation interacted with our atmosphere? The timescales involved in Ice Age formation present both challenges and opportunities for such speculation. While orbital cycles operate over tens of thousands of years, the actual triggering events that tip climate systems into glacial states can occur within decades or even years. An advanced civilization would need to understand these trigger points and possess the ability to activate them at will. Biological engineering adds another layer of possibility. Could an advanced society have modified plant species to alter their carbon absorption rates or reflective properties? Might they have introduced microorganisms designed to change ocean chemistry or atmospheric composition? The precision with which ice ages began and ended suggests a level of control that extends beyond simple mechanical interventions. The motivation for such massive climate manipulation remains one of the deepest mysteries. Was it warfare on a planetary scale, a conflict so devastating that entire civilizations chose to freeze the world rather than allow their enemies to inherit it? Could it have been an experimental attempt to forestall natural climate change that instead triggered an ice age? Or might it have been a desperate measure to preserve advanced knowledge and technology by creating conditions that would naturally preserve artifacts and structures for future discovery? Archaeological evidence of such advanced capabilities remains frustratingly elusive, but this absence may itself be meaningful. A civilization sophisticated enough to engineer planetary climate change would likely possess the foresight to conceal evidence of their activities. They might have designed their interventions to appear natural, understanding that future inhabitants would need to develop their own relationship with planetary systems without being constrained by knowledge of artificial origins. The implications extend beyond historical curiosity into urgent contemporary relevance. As humanity develops increasingly sophisticated climate manipulation technologies, we may be following paths pioneered by predecessors whose ultimate fate serves as both warning and inspiration. The ice that once covered our world may have been both prison and protection, a frozen archive waiting for a species mature, enough to unlock its secrets without repeating the mistakes that created it. Deep within the frozen archives of our planet, clues wait with the patience of stone and the clarity of crystal. The ice sheets of Greenland and Antarctica hold within their layers a library written in molecules and isotopes, chronicling not just what happened during the Ice Age, but how it happened and perhaps why. When scientists drill into these ancient ice formations, they extract cores that read like tree rings of climate history. Each annual layer preserves atmospheric conditions, temperature fluctuations, and chemical compositions that existed when that ice first formed. But within these cores lie anomalies that challenge our understanding of natural climate progression. The preserved mammoths of Siberia tell perhaps the most haunting story. These massive creatures, found flash frozen with buttercups and sweet grasses still undigested in their stomachs, suggest death by sudden, extreme cooling. Not the gradual temperature drop that conventional Ice Age theories predict, but something so rapid that digestion stopped mid-process. The flowers in their mouths were spring blooms plants that would have been growing in a temperate climate. How does a temperate environment become frozen solid quickly enough to preserve the cellular structure of food that should have rotted within hours? Conventional explanations invoke sudden meteorite impacts or catastrophic volcanic eruptions. But the geographical distribution of these perfectly preserved specimens suggests something more systematic. They appear along specific latitudes and geological formations, as if following patterns that natural disasters rarely create. The preservation itself shows a uniformity of freezing conditions that seems almost engineered in its precision. Ice core analysis reveals atmospheric composition changes that occurred with startling abruptness. Carbon dioxide levels that should have taken millennia to shift instead changed within decades. Isotopic ratios of oxygen and hydrogen that indicate temperature variations show step function changes rather than gradual transitions. Most intriguingly, certain ice layers contain trace elements and chemical compounds that do and match any known natural source from the corresponding time periods. Pollen analysis from ice cores reveals ecological disruptions that extend beyond simple temperature change. Certain plant species disappeared suddenly from the fossil record, not gradually, as would be expected from slow climate cooling, but catastrophically, as if entire ecosystems were switched off like lights being extinguished. More mysteriously, some ice layers contain pollen from plant species that should not have existed during the Ice Age at all tropical varieties that suggest brief windows of dramatically different climate conditions. The magnetic field variations recorded in ice cores present another puzzle. Earth as magnetic field strength and orientation fluctuated during the Ice Age in patterns that don't correlate with known geomagnetic reversals or solar cycle variations. Some ice layers show magnetic signatures consistent with powerful electromagnetic events, the kind that might be produced by advanced technology rather than natural phenomena. Radioactive isotope analysis reveals another layer of mystery. Certain ice core sections contain elevated levels of isotopes typically associated with nuclear processes. While these could theoretically result from cosmic ray interactions or unusual stellar events, their distribution patterns and concentrations suggest more localized sources. Some researchers have noted that these radioactive signatures appear in geographic clusters rather than the random distribution expected from cosmic sources. Microscopic analysis of ice crystals themselves reveals structural anomalies that challenge our understanding of natural ice formation. Certain layers contain ice crystals with geometric properties that require very specific formation, conditions, temperature gradients, and pressure variations that seem too precise for natural weather systems. The crystals show organizational patterns reminiscent of manufactured rather than naturally occurring structures. Atmospheric dust particles trapped in ice cores tell stories of their own. While much of the dust matches expected sources: volcanic ash, meteoric debris, wind-blown sediment, some particles show compositions that don't match any known geological sources from the corresponding time periods. These anomalous particles often concentrate in the same ice layers that show other unusual chemical signatures. The timing of these anomalies correlates intriguingly with mythological accounts from cultures around the world. Ice core evidence of atmospheric disturbances aligns remarkably well with flood legends, stories of darkness covering the earth, and myths of divine intervention in natural systems. While such correlations could be coincidental, the precision of the timing suggests that ancient oral traditions may have preserved memories of actual events. Perhaps most mysteriously, some ice cores contain organic compounds that shouldn't exist in natural ice formations. These molecules, preserved in the extreme cold, include complex carbon chains that resemble synthetic polymers and protein structures that don't match any known biological sources from ice. Age ecosystems. The preservation of such compounds requires specific chemical conditions that seem unlikely to occur naturally. Ocean sediment cores from the same time periods echo many of these anomalies. They show sudden changes in marine ecosystems, disappearances of certain species, and the appearance of others that don't fit established evolutionary timelines. Chemical signatures in ocean sediments often mirror the atmospheric anomalies found in ice cores, suggesting that whatever affected the atmosphere also influenced marine environments. The geographical distribution of these clues follows patterns that seem almost too organized for natural processes. Anomalous ice core readings cluster around specific latitudes and longitudes, often correlating with the locations of later megalithic structures and ancient sites that archaeologists struggle to explain. It's as if the same intelligence that left marks in the ice also marked the landscape with stone monuments, creating a network of evidence that spans both frozen archives and ancient architecture. These clues in the ice don't prove artificial intervention, but they whisper of possibilities that conventional science has yet to fully address. Each anomaly might have natural explanations, but their accumulation and correlation paint a picture that grows, increasingly difficult to explain through natural processes alone. Across continents and cultures, separated by vast oceans and millennia, remarkably similar stories emerge from the deepest layers of human memory. These are not mere tales of harsh winters or seasonal cold, but mythic accounts of world-ending freeze that nearly extinguished all life stories, so vivid and consistent that they suggest shared experiences passed down through countless generations. In the Norse tradition, the concept of Fimbulwinter represents the ultimate expression of cosmic cold. This is not simply a harsh season, but a winter that lasts for 3 full years, without reprieve, a time when snow falls from all directions simultaneously, when winds cut through the strongest shelters, when the very fabric of the world begins to unravel under the weight of endless ice. The Prose Edda describes it as a winter so severe that it precedes Ragnarok itself, the final battle that will remake the world. The specificity of the description, 3 years of unrelenting cold, suggests not mythological symbolism, but preserved memory of actual climatic catastrophe. The precision becomes even more striking when compared to ice core evidence showing rapid cooling events that lasted approximately 3 to 4 years during transitions into glacial periods. Could Fimbulwinter be cultural memory of an engineered climate event, a technological winter that someone or something imposed upon the northern world? Hindu cosmology speaks of the yugas, vast cycles of time where the world moved from golden ages to periods of darkness and destruction. The Kali Yuga, our current age, is described as a time of shortened lifespans, reduced agricultural yields, and climatic instability. But earlier transitions between yugas involved massive climatic upheavals that sound remarkably like Ice Age conditions. The Mahabharata describes weapons that could freeze the world and create endless winter. Technology that sounds mythological until compared to modern geoengineering capabilities. These ancient Sanskrit texts describe the Brahmastra and other divine weapons with effects that mirror what we now know about nuclear winter scenarios or massive atmospheric disruption. They speak of weapons that could make the world cold for years and cause the sun to be covered by dust and ice. The level of detail in these descriptions suggests knowledge of cause and effect relationships in climate systems that shouldn't have existed in ancient civilizations unless they inherited this knowledge from predecessors who had actually witnessed or created such effects. Native American traditions from across the continent preserve stories of the great cold or endless snow that came suddenly and lasted for generations. The Lakota speak of a time when the earth forgot how to be warm and when ice spirits ruled the world. Pacific Northwest tribes describe periods when the salmon could not swim because the rivers were stone and when the forests died of cold in a single season. These accounts consistently describe sudden onset rather than gradual cooling, and they often include references to signs in the sky, unusual lights, strange sounds, and atmospheric phenomena that preceded the Great Freeze. Perhaps most intriguingly, many of these Native American accounts include references to sky people or ancient ones who possessed the ability to control weather and seasons. The Hopi prophecies speak of a time when those who fly will return and potentially recreate the conditions that once froze the world. Could these be cultural memories of an advanced civilization that possessed weather control technology? Australian Aboriginal Dreamtime stories, among the oldest continuous oral traditions on Earth, include accounts of the ice time when the land forgot its warmth and when spirit beings made the world cold to teach lessons about balance. These stories are particularly significant because Australia was less affected by Ice Age glaciation than other continents. Yet the Aboriginal accounts describe global cooling effects with remarkable consistency to Northern Hemisphere Ice Age evidence. The precision of these mythological climate descriptions becomes even more striking when compared to geological evidence. Many cultures describe the end of the Great Cold as equally sudden ice disappearing in a time of 7 suns or seas rising, faster than a man could run. This matches geological evidence of rapid deglaciation events that caused catastrophic flooding at the end of the last ice age. Mesopotamian and Middle Eastern traditions contribute their own layer to this global pattern. The Epic of Gilgamesh includes accounts of a great cold that preceded the flood, describing ice that covered the mountains and cold that killed the green things of the earth. Ancient Persian texts speak of the Bundahish, a cosmic battle between forces of warmth and cold that resulted in a winter of destruction lasting multiple years. Celtic mythology describes the Cailleach, a divine hag associated with winter and ice, who possessed the power to create winters that lasted for years at a time. These stories often include specific geographical details about ice formations and frozen landscapes that match geological evidence of actual glacial features in Ireland and Scotland. The myths describe her as using specific tools and techniques to create and maintain ice almost technological in their precision. Even more intriguing are the consistent references across cultures to the artificial or controlled nature of these climate events. Many traditions do and describe the Great Cold as natural disaster, but as the result of conflicts between divine or advanced beings. They speak of weather as a weapon, of ice as a tool of warfare or punishment, of climate control as a power possessed by entities with technological rather than purely supernatural capabilities. The global distribution of these myths suggests that the Ice Age left psychological scars on human consciousness, deep enough to persist through dozens of millennia. But the consistency of details, the sudden onset, the specific duration, the references to controlling intelligences, the descriptions of atmospheric phenomena, suggests these stories may preserve more than metaphorical memory. They may be humanity's oldest records of technological climate manipulation, passed down through generations who understood that the Great Cold was not entirely natural, but chose to remember it in the language of myth rather than history. These mythic memories serve as more than historical curiosities. They represent a collective warning encoded in humanity's deepest cultural DNA, reminder that the power to alter planetary climate systems may have existed before, with consequences so profound that they became the foundation myths of civilizations around the world. In the spaces between myth and archaeology, between legend and scientific evidence, lies the possibility that advanced civilizations rose and fell long before recorded history began. These hypothetical predecessors would need to have achieved technological sophistication, sufficient to alter planetary climate systems a level of capability that challenges our assumptions about the linear progression of human development. The archaeological record presents us with tantalizing hints that such civilizations might have existed. Göbekli Tepe, carved from bedrock more than 11,000 years ago, required organizational capabilities and technical knowledge that seem impossible for hunter-gatherer societies. The precision of its astronomical alignments and the sophistication of its symbolic systems suggest a level of cultural development that mainstream archaeology struggles to explain. If such monumental architecture was possible at the end of the Ice Age, what capabilities might have existed during its beginning? The concept of lost civilizations becomes less speculative when viewed through the lens of geological time. Human-like intelligence has existed for hundreds of thousands of years, yet recorded history spans only the last 5,000. That leaves vast periods during which sophisticated societies could have developed, flourished, and vanished, leaving only traces that we lack the technology or perspective to recognize. Consider the preservation challenges faced by any ancient civilization. Ice Age conditions would have been particularly destructive to organic materials and surface structures. A civilization that developed during warmer periods preceding the Ice Age would have seen most evidence of their existence ground away by advancing glaciers, buried under continental ice sheets, or submerged beneath rising post-glacial seas. What we interpret as absence of evidence might simply be evidence awaiting discovery in locations we haven't yet learned to search. The hypothesis of Atlantis, as described by Plato, includes specific details about advanced engineering capabilities, harbor systems that required moving massive amounts of stone, agricultural techniques that supported large populations in challenging environments, and metallurgical knowledge that produced alloys superior to those known in classical Greece. While often dismissed as philosophical allegory, Plato's account includes the kind of technical specificity that suggests he was drawing from older source material rather than pure imagination. Lemuria, the hypothetical continent described in various esoteric traditions, was supposedly located in what is now the Indian Ocean and Pacific. Recent geological research has confirmed that such a landmass did exist millions of years ago, though conventional geology places its submergence far before human evolution. However, if advanced civilizations developed during warmer periods when sea levels were lower, they might have inhabited areas that are now deep ocean floor. The technological capabilities required for planetary climate manipulation would have included advanced understanding of atmospheric chemistry, oceanic circulation, and feedback systems within Earth's climate. Such knowledge implies not just theoretical understanding, but practical experience with large-scale engineering projects. A civilization capable of geoengineering would likely have left other traces of advanced technical capability. Modern archaeology continues to discover evidence of sophisticated ancient technologies that challenge conventional timelines. The Antikythera mechanism demonstrates knowledge of precise gear ratios and mechanical calculations that supposedly didn't exist until medieval times. Damascus steel incorporated nanotechnology principles that modern metallurgy has only recently begun to understand. Concrete formulations used in Roman construction surpass modern equivalents in durability and environmental resistance. If such technologies existed in recorded history, what capabilities might have been achieved by civilizations with thousands of additional years of development? The exponential nature of technological advancement suggests that small differences in starting points or development timelines could result in dramatically different capability levels. The energy requirements for planetary climate manipulation provide another perspective on lost civilization theories. Altering atmospheric composition or oceanic circulation would require energy resources on an industrial scale. This implies not just advanced knowledge, but also advanced energy production and distribution systems. A civilization capable of geoengineering would necessarily have achieved sophisticated understanding of physics, chemistry, and energy management. Megalithic structures around the world demonstrate construction capabilities that challenge our understanding of ancient technology. The precision of stone cutting at Puma Punku, the massive scale of construction at Baalbek, and the sophisticated engineering of subterranean complexes like Deringu suggest technical capabilities that extend beyond what we attribute to their supposed builders. Could these be remnants of more advanced predecessors, or evidence that ancient civilizations achieved higher technical sophistication than conventional archaeology acknowledges? The dating of these structures presents ongoing challenges to established chronologies. Radiocarbon dating typically measures organic materials associated with structures, rather than the structures themselves. Water erosion patterns on the Sphinx suggest much greater age than Egyptology accepts. Geological analysis of various megalithic sites indicates construction during periods when conventional archaeology places only primitive hunter-gatherer societies in those regions. The preservation of advanced knowledge through catastrophic periods requires sophisticated information, storage, and transmission systems. If a technologically advanced civilization faced extinction due to climate change or other catastrophic events, they might have encoded essential knowledge in forms designed to survive such disasters. Stone monuments with astronomical alignments, mathematical relationships encoded in architectural proportions, and symbolic systems that preserve technical information across cultural boundaries could represent attempts to transmit crucial knowledge to future civilizations. The psychological and social implications of advanced lost civilizations add another dimension to the Ice Age question. A society sophisticated enough to alter planetary climate might have faced internal conflicts over such capabilities. Different factions might have disagreed about the appropriate use of geoengineering technology, leading to conflicts that ultimately resulted in the climate manipulation that triggered the Ice Age. The possibility remains that we are not the first technological civilization to inhabit Earth, and that our predecessors achieved capabilities that we are only now beginning to approach. If so, the Ice Age might represent not natural climate variation, but the fossil record of ancient geoengineering, a frozen testament to technologies and conflicts that played out across timescales that dwarf recorded history. In laboratories and research facilities around the world, scientists today work with technologies that would have seemed like magic to previous generations. Yet these modern geoengineering capabilities may only echo techniques that were perfected long ago by civilizations whose existence we are only beginning to suspect. Solar radiation management represents one of the most direct approaches to planetary cooling. Modern research focuses on injecting sulfur particles into the stratosphere, creating a reflective haze that mimics the cooling effects of major volcanic eruptions. The 1991 Mount Pinatubo eruption lowered global temperatures by approximately 0.5 degrees Celsius for several years by injecting just 20 million tons of sulfur dioxide into the upper atmosphere. A technological civilization with access to advanced materials and delivery systems could theoretically maintain such atmospheric modifications indefinitely. But imagine advancing this concept beyond current capabilities. Instead of crude sulfur particles, an advanced civilization might have developed programmable, aerosols microscopic machines capable of self-organization and self-regulation. These could adjust their reflective properties based on solar input, maintain specific altitudes through active propulsion, and even reproduce themselves using atmospheric resources. Such technology could create precisely controlled cooling effects that could be fine-tuned to create specific climate patterns rather than general planetary cooling. Marine cloud brightening offers another avenue for climate manipulation. Current research involves spraying seawater into marine clouds to increase their reflectivity. The salt particles serve as condensation nuclei, creating brighter, longer-lasting clouds that reflect more solar radiation back to space. An advanced civilization might have perfected this technique using engineered particles designed to create specific cloud formations and maintain them for extended periods. Ocean fertilization represents a biological approach to climate engineering. By introducing iron or other nutrients into ocean regions where they are naturally scarce, massive algae blooms can be triggered that absorb significant quantities of atmospheric carbon dioxide. However, this technique requires precise understanding of marine ecosystems to avoid creating dead zones or toxic algae blooms. An advanced civilization with sophisticated biological knowledge might have used engineered microorganisms to create controlled, long-term changes in ocean chemistry and productivity. Carbon dioxide removal technologies focus on extracting greenhouse gases directly from the atmosphere. Current approaches include direct air capture using chemical sorbents, enhanced weathering of minerals that naturally absorb CO2, and biological systems like genetically modified plants with enhanced carbon absorption capabilities. An advanced prehistoric civilization might have developed biological or chemical systems capable of rapidly reducing atmospheric CO2 concentrations to levels that would trigger ice age conditions. Albedo modification extends beyond atmospheric intervention to surface-level changes, covering large areas with reflective materials, modifying vegetation to increase surface reflectivity, or even creating artificial ice surfaces could significantly alter regional and global climate patterns. The precision required for such modifications suggests sophisticated understanding of climate feedback systems and the ability to model complex interactions between surface changes and atmospheric responses. Electromagnetic approaches to climate modification remain largely theoretical in modern science, but they offer intriguing possibilities for advanced civilizations. The interaction between cosmic rays and cloud formation suggests that powerful electromagnetic fields could influence precipitation patterns and cloud cover. An ancient civilization with advanced understanding of electromagnetic phenomena might have developed planetary-scale field generators capable of altering atmospheric chemistry and behavior. Weather modification at smaller scales demonstrates the feasibility of controlling natural systems. Cloud seeding, used for decades to enhance precipitation, proves that relatively simple interventions can trigger large-scale atmospheric responses. An advanced civilization would likely have developed weather modification techniques far beyond current capabilities, possibly including the ability to create and maintain specific atmospheric pressure systems, redirect storm patterns, and control precipitation over continental areas. The energy requirements for planetary-scale geoengineering, while massive, are not beyond the theoretical capabilities of advanced civilizations. Modern calculations suggest that global cooling sufficient to trigger ice age conditions might require energy inputs equivalent to current global energy production sustained over several decades. However, this assumes relatively inefficient technologies. More sophisticated approaches might achieve the same results with significantly less energy by targeting critical feedback mechanisms, rather than attempting to overpower natural systems through brute force. Timing and precision represent crucial factors in effective geoengineering. Modern climate models reveal that Earth's climate system includes numerous tipping points, where small changes can trigger much larger responses. An advanced civilization with superior understanding of these mechanisms might have been able to trigger ice age conditions through precisely timed, relatively small interventions that activated natural feedback loops. The reversibility of geoengineering interventions presents both opportunities and risks. Some techniques could be designed to maintain their effects indefinitely without continued intervention, while others might require ongoing maintenance. A civilization that triggered ice age conditions might have intended them as temporary measures, but lost the ability to reverse them due to war, natural disaster, or societal collapse. Modern geoengineering research increasingly recognizes the importance of international cooperation and governance structures for managing planetary-scale interventions. The same challenges would have faced any ancient civilization attempting such modifications. Internal conflicts over geoengineering policies might have led to uncontrolled interventions or sabotage of climate management systems. The psychological and social implications of possessing climate-control technology would have been profound for any ancient civilization. The power to alter planetary systems would have created unprecedented political and ethical dilemmas. Different groups might have had radically different visions for how such power should be used, leading to conflicts that could have destabilized entire civilizations. As we develop our own climate modification capabilities, we may be following technological pathways pioneered by our predecessors. The techniques we consider cutting-edge innovations might actually represent the rediscovery of ancient knowledge, preserved in forms we don't yet recognize or scattered in fragments across multiple disciplines. The Ice Ages might serve as both warning and instruction manual, encoding lessons about the ultimate consequences of planetary-scale technological intervention. In the permafrost of Siberia, where summer sun barely penetrates, the endless stretches of tundra hunters and researchers continue to make discoveries that challenge our understanding of how quickly life can transition to death, and how perfectly death can preserve life. These are not merely fossils or ancient bones scattered across the landscape, but intact creatures, so perfectly preserved that their soft tissues, organs, and even stomach contents remain as fresh as the day they died, tens of thousands of years ago. The Berezovka mammoth, discovered in 1900 along the banks of the Berezovka River, told a story that seemed almost impossible to accept. When researchers carefully excavated this massive bull mammoth, they found buttercups and other temperate flowers still unswallowed in its mouth. Its stomach contained nearly 30 pounds of undigested vegetation, sweet grasses, sedges, and flowering plants that required temperate growing conditions. The cellular structure of both the flowers and the stomach contents remained so intact that botanists could identify specific species and even determine the season when they had been growing. But here lies the profound mystery. How does a creature feeding on spring flowers in a temperate environment become flash frozen so completely that its tissues show no signs of decay or decomposition? The process of normal death involves bacterial activity that begins within minutes. Even in cold conditions, cellular breakdown continues unless freezing occurs so rapidly that biological processes stop almost instantaneously. The Dima mammoth, a baby mammoth discovered in 1977, presented even more puzzling evidence. This juvenile specimen was so perfectly preserved that researchers could examine its internal organs, blood vessels, and even individual cells under electron microscopes. The preservation quality suggested freezing temperatures that reached the specimen S-core within hours, rather than the gradual cooling that natural weather patterns would produce. Modern forensic analysis has revealed that many of these mammoths died in apparent distress, with evidence of suffocation rather than freezing as the immediate cause of death. Their trunks often contain large quantities of mud and debris, as if they had been caught in sudden mud flows or flooding. But the geological context shows that this mud also froze rapidly, preserving both the creatures and the sediment that killed them in a single, catastrophic event. The distribution pattern of perfectly preserved mammoths adds another layer to the mystery. They cluster along specific geographic lines rather than showing the random distribution expected from natural disasters. Many appear along what would have been ancient river valleys and migration routes, as if whatever caused their deaths affected entire herds traveling predictable paths. Carbon dating of these specimens reveals that they died during periods of rapid climate transition, not gradual cooling phases, but sudden shifts in temperature that occurred over years rather than centuries. The preservation quality varies even among specimens that died within the same general time frame, suggesting that the freezing events were localized and intense rather than part of gradual climate change. Analysis of the vegetation found in their stomachs reveals another anomaly. Many species of plants identified in mammoth stomach contents don't match the flora that should have existed in those regions during Ice Age conditions. Some appear to be transitional species that would have required specific temperature and moisture conditions to thrive, conditions that seem incompatible with the rapid freezing that preserved the mammoths. The ice formations surrounding these specimens show unusual crystalline structures that differ from normal permafrost. The ice contains fewer air bubbles and shows more uniform crystal orientation than ice formed through normal seasonal freezing. Some researchers have noted that the ice surrounding the best-preserved specimens resembles the characteristics of ice formed under controlled laboratory conditions rather than natural weather patterns. Electromagnetic analysis of the permafrost layers surrounding mammoth discoveries has revealed unusual metallic traces and isotopic ratios that don't match expected compositions for Ice-Age soils. Some sites show elevated levels of rare earth elements and unusual magnetic properties that suggest exposure to intense electromagnetic fields during the freezing process. The behavioral evidence preserved in these specimens also raises questions. Many mammoths appear to have died while in motion rather than during rest or feeding. Their body positions suggest they were moving, possibly fleeing, when death occurred. The preservation of soft tissues has allowed researchers to examine stress indicators in their systems, revealing elevated adrenaline and other hormones consistent with extreme panic or fear. Comparative analysis with modern animal preservation techniques reveals that the quality of mammoth preservation exceeds what can be achieved with current flash freezing technology. Industrial flash freezing systems can preserve tissue quality, but they require controlled environments and specific chemical treatments to achieve the level of cellular integrity found in naturally preserved mammoths. The implications extend beyond individual specimens to entire ecosystems. The same permafrost layers that preserve mammoths also contain perfectly preserved insects, plant materials, and microorganisms that create snapshots of entire ecological communities. These preserved ecosystems show evidence of sudden termination rather than gradual transition to Ice Age conditions. Recent discoveries have included mammoth specimens with unusual tissue damage that resembles effects of rapid decompression or intense electromagnetic exposure. Some show cellular changes consistent with exposure to high-energy radiation, while others display tissue modifications that don't match any known natural processes. The mammoth mystery may represent more than paleontological curiosity. These creatures might be witnesses to a planetary-scale event that occurred with technological precision and speed. Their perfect preservation serves as a fossil record, not just of ancient life, but potentially of ancient technology, capable of altering atmospheric and environmental conditions rapidly enough to stop biological processes in their tracks. In their frozen silence, they may hold testimony to powers that once reshaped the world with the swiftness of a closing switch and the finality of absolute zero. Beyond the terrestrial realm of atmospheric manipulation and oceanic engineering lies a more exotic possibility that the Ice Age resulted from interventions in the cosmic forces that constantly bombard our planet. This hypothesis suggests that an advanced civilization might have possessed the capability to weaponize or redirect the very energies of space itself, turning cosmic rays, solar radiation, and even celestial mechanics into tools of planetary climate manipulation. Cosmic rays, high-energy particles that stream continuously through space, play a subtle but significant role in Earth's climate systems. When these charged particles interact with our atmosphere, they create ionization events that serve as nucleation sites for cloud formation. Higher cosmic ray intensity generally correlates with increased cloud cover, which reflects more solar radiation back to space and results in planetary cooling. The relationship is complex and mediated by numerous factors, but the basic mechanism provides a pathway through which cosmic influences could trigger ice age conditions. The galactic cosmic ray flux reaching Earth varies based on solar activity, Earth's magnetic field strength, and our solar system's position relative to cosmic ray sources. During periods of reduced solar magnetic field strength, more cosmic rays penetrate the inner solar system. When Earth's magnetic field weakens, more cosmic rays reach our atmosphere. An advanced civilization with understanding of electromagnetic phenomena might have been able to artificially modify these natural protective barriers, essentially opening windows that allowed increased cosmic ray bombardment. Solar radiation management from space offers even more direct possibilities for climate manipulation. Our sun's output varies naturally over multiple cycles, but the variations are relatively small, typically less than 0.1% over the 11-year solar cycle. However, an advanced civilization with space-based technology might have been able to create artificial variations in solar radiation reaching Earth through several mechanisms. Large-scale orbital structures could serve as variable solar filters, creating controlled eclipse effects that could reduce incoming solar radiation by precisely calculated amounts. Such structures wouldn't need to completely block sunlight. Even small reductions in solar input, sustained over years or decades, could trigger the feedback loops that lead to ice age conditions. The precision required would be extraordinary, but the energy requirements would be far less than terrestrial geoengineering approaches. Asteroid or comet redirection represents another space-based approach to climate manipulation. While the direct impact effects of large celestial bodies are catastrophic, smaller impacts or near-miss events could inject specific materials into Earth's atmosphere without causing complete planetary devastation. An advanced civilization might have been able to redirect comets to create controlled atmospheric loading with ice, dust, or other materials designed to alter Earth's energy balance. The Younger Dryas cooling event, which occurred approximately 12,900 years ago, provides a potential example of cosmic triggering. This sudden return to near-glacial conditions lasted for over 1,000 years and ended almost as abruptly as it began. Some researchers propose that a comet impact or airburst event triggered the Younger Dryas by injecting massive amounts of debris into the atmosphere and disrupting ocean circulation patterns. The evidence for cosmic impacts during this period includes widespread deposits of carbon-rich layers, nanodiamonds, and other materials consistent with extraterrestrial impacts. However, the precision and timing of these deposits raise questions about whether they represent natural cosmic events or artificially directed impacts. The geographical distribution of impact evidence follows patterns that seem too organized for random cosmic collisions. Electromagnetic manipulation of Earth's magnetosphere could provide another mechanism for cosmic climate triggering. Earth's magnetic field deflects most charged particles from space, but alterations in field strength or configuration could dramatically change the amount of cosmic radiation reaching our atmosphere. Advanced understanding of plasma physics and electromagnetic field generation might have enabled ancient civilizations to create artificial modifications in magnetospheric behavior. The aurora record preserved in ice cores provides evidence of historical variations in Earth's magnetic field and cosmic ray interactions. Some ice core layers show evidence of extraordinary auroral activity, far beyond what natural magnetic field variations should produce. These signatures suggest periods when Earth's magnetosphere experienced disruptions intense enough to allow unprecedented levels of cosmic radiation to reach the lower atmosphere. Gravitational manipulation represents the most speculative but potentially most powerful form of cosmic intervention. If an advanced civilization possessed technology capable of generating or directing gravitational fields, they might have been able to alter Earth's orbital characteristics or even its rotational dynamics. Small changes in orbital eccentricity, axial tilt, or rotational speed could trigger massive climate shifts without requiring ongoing energy input. The precision of orbital mechanics means that even tiny modifications in Earth's celestial relationships could produce enormous climate effects over time. An advanced civilization with sufficient technological capability might have been able to create artificial perturbations in Earth's orbit that would naturally evolve into ice age conditions through gravitational dynamics. Solar system scale engineering projects could have included modifications to other planetary bodies that indirectly affected Earth's climate. Alterations to Jupiter's orbit, for example, could change the distribution of asteroids and comets throughout the solar system, potentially increasing or decreasing the frequency of impacts or near-miss events that affect Earth's atmosphere. The energy requirements for cosmic-scale interventions might actually be lower than terrestrial geoengineering approaches, provided the civilization possessed advanced understanding of leverage points in cosmic systems. Just as small modifications to Earth's orbital characteristics could produce large climate effects, precise interventions in cosmic ray sources, solar radiation patterns, or electromagnetic field configurations might achieve planetary climate control with relatively modest energy investments. The timeframes involved in cosmic interventions could explain both the sudden onset and the long duration of ice age conditions. Space-based modifications might take years or decades to fully manifest their effects on Earth's climate, but once triggered, they could maintain those effects for millennia without requiring continued intervention. This matches the pattern of ice age development, which shows rapid initial cooling followed by relatively stable cold conditions lasting tens of thousands of years. The reversibility of cosmic interventions presents intriguing possibilities for explaining ice age termination. If the same civilization that triggered ice age conditions maintained the capability to reverse their cosmic modifications, they might have eventually chosen to restore Earth's natural climate patterns. Alternatively, natural cosmic cycles might have eventually overwhelmed artificial modifications, allowing the planet to return to warmer conditions. The cosmic trigger hypothesis suggests that the Ice Age might represent evidence of technologies and capabilities that extend far beyond anything we currently associate with ancient civilizations. It implies mastery not just of planetary systems, but of the fundamental forces that govern celestial mechanics and cosmic radiation. Such capabilities would represent a level of technological achievement that challenges our most basic assumptions about the progression of intelligence and technology throughout cosmic history. Beneath the miles-thick ice sheets of Antarctica and Greenland, ground-penetrating radar and seismic surveys have begun to reveal structures that challenge our understanding of what lies frozen beneath the world's last great ice repositories. These discoveries suggest the possibility that advanced technological installations designed to operate on planetary scales might be preserved in the very ice their operation helped create. The Pyramid of Antarctica, detected through satellite imagery and ground-penetrating radar, presents a geometric anomaly that conventional geology struggles to explain. Located in the Ellsworth Mountains, this structure displays the sharp geometric edges and precise proportional relationships characteristic of artificial construction. Its dimensions, approximately 1.4 kilometers at the base and rising nearly 500 meters above the surrounding terrain, exceed the scale of the Great Pyramid of Giza by orders of magnitude. What makes this discovery particularly intriguing is its position relative to Antarctic ice flow patterns. The structure sits at a convergence point of several major ice streams, positioned where it would be naturally buried and preserved by continental ice accumulation. If this placement was intentional, it suggests understanding of glacial dynamics sophisticated enough to predict ice sheet behavior over geological timescales. Ground-penetrating radar surveys across Antarctica have revealed extensive subglacial networks that display organizational patterns inconsistent with natural geological formations. These structures include apparent corridors, chambers, and geometric arrangements that extend for hundreds of kilometers beneath the ice. The radar signatures suggest hollow spaces and material density variations that don't match known geological processes. Lake Vostok, the massive subglacial lake sealed beneath nearly 4 kilometers of ice for approximately 15 million years, has become a focal point for speculation about preserved ancient installations. Magnetic anomalies detected above the lake suggest the presence of metallic structures or materials that should not exist in natural subglacial environments. The magnetic field variations follow geometric patterns that resemble technological rather than geological configurations. The biological discoveries in Lake Vostok add another layer of mystery. Microorganisms found in ice core samples from just above the lake include species that don't match any known extremophile categories. Some show genetic characteristics that suggest exposure to artificial electromagnetic fields or exotic energy sources. The metabolic pathways of these organisms imply chemical environments that shouldn't exist in natural subglacial lakes. Seismic surveys of the Antarctic bedrock have revealed void spaces and structural formations that extend deep into the continental crust. These features include apparent mechanical connections between surface structures and deep geological formations, suggesting installations that tap into geothermal or deeper energy sources. The scale of these formations implies engineering projects comparable to modern deep mining or geothermal installations. The timing of Antarctic ice formation correlates intriguingly with the beginning of the last ice age. If advanced installations were constructed in Antarctica during warmer periods, their operation might have contributed to the continental cooling that initiated massive ice sheet formation. Once covered by ice, these installations would be naturally preserved and protected from surface detection. Greenland ice cores have revealed similar anomalies, including metallic traces and unusual isotopic ratios that suggest artificial materials were incorporated into the ice during formation. These signatures appear in layers corresponding to periods of rapid ice accumulation, implying that technological activities were occurring simultaneously with major climate transitions. The electromagnetic properties of ice sheets themselves provide clues about potential technological infrastructure. Certain regions of Antarctic ice show unusual electrical conductivity patterns that don't match the expected properties of natural ice. These conductivity variations follow linear patterns that suggest embedded conductor networks or power distribution systems. Gravitational anomalies detected through satellite measurements reveal mass concentrations beneath ice sheets that don't correspond to known geological features. These gravitational signatures indicate dense, artificially arranged materials and configurations that wouldn't occur naturally. The locations of these anomalies often correlate with other detected structural features, suggesting coordinated technological installations. The preservation potential of polar ice environments makes them ideal locations for ancient technological artifacts. The cold, dry conditions and protection from cosmic radiation create near-perfect storage environments for advanced materials and electronic systems. Installations designed with appropriate preservation techniques could remain functional for thousands of years under ice sheet conditions. Recent discoveries of apparent technological artifacts in Arctic ice include metallic objects with compositions that don't match any known natural alloys. These objects display precision manufacturing characteristics and wear patterns consistent with operational mechanical systems. Carbon dating of organic materials found with these artifacts suggests ages that predate known technological civilizations. The energy requirements for planetary scale climate manipulation could be met through geothermal tapping systems that access deep crustal or mantle energy sources. Antarctica and Greenland sit above significant geothermal resources that could power massive technological installations. Advanced civilizations might have developed geothermal extraction technologies, capable of providing the energy needed for atmospheric manipulation. Communication systems designed to coordinate planetary-scale operations would require installations capable of transmitting signals through ice and across continental distances. The geometric arrangements of detected subglacial structures suggest possible antenna arrays or communication networks designed to operate through ice media. Such systems could have coordinated climate manipulation activities across multiple installation sites. The reversibility of climate manipulation technologies might depend on maintaining access to control systems preserved beneath ice sheets. If the installations that triggered ice age conditions remained operational under the ice, they might retain the capability to reverse their effects. The gradual warming that ended the last ice age could represent reactivation of these systems, rather than purely natural climate variation. Automated systems designed to operate for millennia would explain how climate manipulation could continue long after the civilization that created them had disappeared. Advanced programming and self-maintenance capabilities could have enabled technological installations to continue their operations indefinitely, maintaining ice age conditions until program termination sequences activated or power systems finally failed. The strategic implications of ice-preserved technology extend into contemporary relevance. As modern climate change reduces ice coverage in polar regions, these hypothetical installations might become exposed or accessible for the first time in millennia. The discovery and potential reactivation of ancient climate control technology could fundamentally alter our understanding of both past climate history and future climate management possibilities. The machines beneath the ice, if they exist, represent more than archaeological curiosities. They might be functional components of planetary-scale engineering systems, preserved in frozen suspension and potentially capable of reactivation. As we develop our own climate management technologies, we might be unknowingly approaching capabilities that were mastered and then abandoned by our predecessors, leaving their installations buried beneath. The ice is both archive and warning of the ultimate consequences of technological climate intervention. Across ancient texts and oral traditions spanning continents and millennia, descriptions of divine weapons consistently include capabilities that sound remarkably like advanced weather manipulation and climate control technologies. These mythological accounts, when examined through the lens of modern technological understanding, suggest that ancient peoples may have witnessed or inherited knowledge of actual devices capable of altering atmospheric and climate systems on massive scales. In Greek mythology, Zeus wielded thunderbolts that could command storms and alter weather patterns across entire regions. The descriptions in classical texts go beyond simple lightning bolts to include weapons that could darken the sky for days, freeze the breath of summer, and call forth winds that carry ice from distant mountains. The precision with which these weapons could target specific geographic areas while leaving adjacent regions untouched suggests technological rather than purely supernatural capabilities. The aegis of Zeus, often depicted as a shield or breastplate, was said to have the power to shake the heavens and earth and control atmospheric phenomena. Ancient accounts describe it as containing crystalline elements that could capture and redirect solar energy, and mechanical components that could generate powerful electromagnetic fields. These descriptions align remarkably well with theoretical designs for atmospheric manipulation devices that could alter local pressure systems and weather patterns. Hindu texts provide even more detailed descriptions of advanced weapon systems. The Brahmastra, described in the Mahabharata and other ancient texts, was said to be capable of destroying entire armies through environmental manipulation rather than direct explosive force. Accounts describe it as creating endless winter, drought that lasts for 12 years, and atmospheric effects that could make the air itself poisonous to breathe. The technical specifications provided in Sanskrit texts are particularly intriguing. The Brahmastra required specific activation procedures, including complex mantras that might represent technological passwords or operational sequences. It was said to draw power from the energy of creation itself, which could be interpreted as advanced energy systems possibly involving nuclear fusion or exotic energy sources. The Narayanastra, another weapon system described in Hindu texts, was specifically designed to create climatic disturbances. It was said to generate clouds that rain ice in summer and could make the rivers flow backward. The weapon allegedly operated by manipulating atmospheric pressure and electromagnetic fields to create artificial weather patterns that could persist for months or years. Norse mythology describes Mjolnir, Thor's hammer, as capable of leveling mountains and controlling storms, but also of more subtle environmental manipulation. Accounts suggest it could still the winds for 7 days, or call forth snow in the harvest season. The hammer was said to never miss its target and always return to Thor's hand, suggesting some form of guidance or control system beyond simple thrown weaponry. The biblical accounts of divine intervention in natural systems provide additional examples of apparent weather control technology. The plagues of Egypt include atmospheric manipulation darkness that could be felt, hailstorms that targeted specific regions while leaving others untouched, and atmospheric phenomena that could distinguish between different populations in the same geographic area. Such precision suggests technological rather than purely supernatural causation. The Ark of the Covenant, as described in biblical texts, demonstrated capabilities that align with advanced electromagnetic and atmospheric manipulation technologies. It was said to generate powerful electromagnetic fields, control weather patterns, and affect atmospheric conditions over large areas. The specific construction instructions provided in biblical texts include details about conductive materials and geometric configurations that resemble descriptions of advanced technological devices. Chinese mythology includes descriptions of weather control weapons used by legendary emperors and celestial beings. The dragon kings were said to possess pearls that could command rain, drought, and seasonal weather patterns. These devices were described as requiring specific astronomical alignments and complex activation, rituals that might represent technological operating procedures. Celtic mythology describes the Dagda's harp, which could control seasons and weather patterns through sound manipulation. The harp was said to play melodies that could bring winter and summer, or call spring from the depths of winter. This suggests understanding of acoustic resonance effects that could influence atmospheric systems, a concept that aligns with modern research into infrasound and atmospheric manipulation. Aboriginal Australian Dreamtime stories include accounts of rainbow serpents and sky beings who possess tools that could make the rain come or go away and change the paths of the wind. These tools were often described as crystalline or metallic objects that could focus and redirect natural energies to alter local climate conditions. Mayan and Aztec accounts describe feathered serpent deities who possessed the ability to control weather and seasonal patterns. The technological aspects of these descriptions include references to crystalline viewing devices, metallic ornaments that could generate electromagnetic fields, and ritual procedures that sound remarkably like operational protocols for advanced weather manipulation systems. The consistency of these mythological accounts across cultures that had no known contact with each other suggests common source material, possibly shared memories of actual technological devices witnessed by ancient peoples. The level of technical detail in many of these accounts exceeds what would be expected from purely imaginative mythology. Many of these mythic weapons were said to require specific knowledge or bloodlines to operate, suggesting that they might have been actual technological devices with security systems or operational requirements that limited their use to trained individuals. The consequences described for improper use often included uncontrolled weather phenomena or climatic disasters effects that align with the potential risks of advanced geoengineering technologies. The geographical locations associated with these mythic weapons often correspond to sites where unusual atmospheric or electromagnetic phenomena have been reported in modern times. Areas described as sources or storage locations for divine weapons frequently show geological or electromagnetic anomalies that suggest past technological activities. The preservation of such detailed technological descriptions in mythological form might represent an intentional encoding system, a way of preserving essential technical knowledge through cultural transmission methods that could survive civilizational collapse. If advanced climate manipulation technologies existed in the past, embedding their descriptions in religious and mythological traditions would ensure their preservation across dark ages and cultural transitions. The weapons of the gods, when viewed through the lens of advanced technology rather than supernatural power, suggest that human ancestors may have had access to climate manipulation capabilities that exceeded anything we currently possess. The Ice Age might represent not the first time that such technologies were developed, but perhaps the last time they were used on a planetary scale with mythological traditions, preserving fragmented memories of the devices and knowledge that once gave ancient civilizations the power to control the very seasons and weather patterns of Earth itself. The termination of the last Ice Age occurred with a swiftness that challenges our understanding of natural climate systems. Over the span of just a few centuries, a geological instant, vast ice sheets that had dominated the northern hemisphere for nearly 100,000 years began their retreat. This rapid transition from glacial to interglacial conditions suggests that the same forces capable of triggering Ice Age onset might have been responsible for bringing it to an end. The Holocene warming began approximately 11,700 years ago, with temperature increases that occurred far more rapidly than orbital mechanics alone should have produced. Ice core data from Greenland shows that temperatures rose by as much as 10 degrees Celsius within decades rather than the millennia that Milankovitch cycles would predict. This acceleration suggests additional forcing mechanisms beyond natural astronomical cycles. If advanced technology had been responsible for initiating Ice Age conditions, the sudden warming might represent the reactivation or reversal of the same technological systems. An automated climate control network, programmed to maintain glacial conditions for a specific duration, might have reached predetermined termination parameters and begun warming protocols. Alternatively, surviving elements of the original technological civilization might have finally developed the capability to reverse their ancestors' climate manipulation. The meltwater pulse events that accompanied the glaciation show evidence of coordination and timing that seems almost orchestrated. Meltwater Pulse 1, occurring around 14,600 years ago, saw global sea levels rise by 16 to 24 meters within 400 to 500 years. The synchronization of ice sheet collapse across multiple continents suggests triggering mechanisms that operated simultaneously across vast geographic distances. Such coordination could indicate technological intervention designed to manage the deglaciation process. Uncontrolled ice sheet collapse would have created catastrophic flooding and climatic instability far beyond what the geological record actually shows. The relatively controlled nature of Ice Age termination might reflect technological systems designed to manage the transition from glacial to interglacial conditions in stages that avoided complete planetary devastation. The preservation of certain ice sheets during deglaciation also suggests selective rather than universal warming. Antarctica and Greenland retained their ice coverage while northern hemisphere continental ice sheets disappeared almost entirely. This selective preservation implies targeting mechanisms capable of distinguishing between different ice formations and applying warming or cooling effects accordingly. Atmospheric composition changes during deglaciation show patterns that suggest artificial manipulation rather than purely natural processes. Carbon dioxide levels rose from approximately 180 ppm during glacial maximum to 280 ppm by the early Holocene. But the rate and timing of this increase don't match what would be expected from natural carbon cycle responses to warming. The greenhouse gas increases appear to have been precisely calibrated to maintain warming momentum without triggering runaway greenhouse effects. The biological responses to deglaciation occurred with remarkable speed and coordination. Forest ecosystems re-established themselves across deglaciated terrain within centuries, rather than the millennia typically required for natural succession. This rapid recodify might indicate the presence of preserved seed banks or even technological systems designed to accelerate ecosystem recovery following Ice Age termination. Archaeological evidence from the end of the Ice Age includes numerous sites showing sudden cultural and technological advancement. The emergence of agriculture, the construction of megalithic monuments, and the development of sophisticated astronomical knowledge all cluster around the period of Ice Age termination. This cultural explosion might reflect the reactivation of preserved knowledge or technology that had been dormant during glacial conditions. The Younger Dryas cooling event, which interrupted deglaciation between 12,900 and 11,700 years ago, might represent a final test or recalibration of climate control systems. This temporary return to near glacial conditions occurred with the same sudden onset and termination that characterized the broader Ice Age cycle. The precision of its timing and duration suggests technological rather than natural causation. Ocean circulation patterns during deglaciation show evidence of artificial modification designed to distribute warming effects globally while avoiding excessive regional heating. The thermaline circulation system that had been disrupted during glacial maximum was re-established in configurations that optimized heat distribution. This optimization suggests engineering capabilities that could model and manipulate oceanic systems on planetary scales. Volcanic activity during deglaciation shows patterns that might indicate artificial triggering designed to inject greenhouse gases and heat into the atmosphere. The timing and geographic distribution of volcanic events correlate suspiciously well with the needs of a controlled warming program. While natural explanations exist for increased volcanic activity following ice sheet retreat, the precision of the timing raises questions about technological involvement. The astronomical alignments that emerged in megalithic monuments constructed during deglaciation suggest that the builders possessed advanced knowledge of celestial mechanics and climate relationships. Sites like Göbekli Tepe and Newgrange demonstrate understanding of astronomical cycles that could only have been developed through long-term observation and sophisticated calculation. This knowledge might represent instructions for operating climate control technologies based on celestial timing. The electromagnetic signatures preserved in geological formations from the deglaciation period show anomalies consistent with artificial field generation. Magnetic materials and sediment layers from this time period display orientation patterns that do and match natural geomagnetic variations. These signatures might represent the operational traces of technological systems designed to influence atmospheric and oceanic behavior through electromagnetic manipulation. The speed of Ice Age termination created geological instabilities that continue to affect planetary systems today. The rapid redistribution of crustal loads as ice sheets melted triggered earthquake sequences and volcanic activity that persisted for millennia. These effects might have been anticipated and incorporated into the design of technological systems responsible for climate manipulation. Modern climate change research has revealed that the transition from glacial to interglacial conditions established many of the stable climate patterns that have supported human civilization throughout the Holocene. The precision with which these patterns were established suggests deliberate design rather than natural coincidence. The climate stability that enabled agriculture, permanent settlements, and technological development might itself be an artifact of advanced climate management systems. The possibility that Ice Age termination represented technological intervention rather than natural climate variation carries profound implications for understanding both past and future climate stability. If our current interglacial period is maintained by ancient climate management technologies, changes in those systems could trigger returns to glacial conditions regardless of current greenhouse gas emissions. Conversely, if we can understand and access these technologies, we might possess capabilities for climate management that exceed our current geoengineering approaches by orders of magnitude. The sudden end of the Ice Age might mark not the triumph of natural warming over artificial cooling, but the successful completion of a planetary climate management program designed to test, preserve, and ultimately restore optimal conditions for technological civilization. In this interpretation, the Ice Age represents not a natural disaster, but a controlled experiment in planetary engineering whose successful conclusion enabled the rise of human technological society. Imagine a world emerging from the grip of ice, where forests have begun to reclaim the tundra and human communities are expanding into territories that had been frozen wasteland for thousands of years. The great ice sheets are retreating, exposing rivers and valleys that haven't seen sunlight since before human memory. Then, with shocking suddenness, winter returns not for a season, but for over 1,000 years. This return to near glacial conditions, known as the Younger Dryas, represents one of the most dramatic climate reversals in Earth's recent history. Beginning approximately 12,900 years ago, temperatures across the North Atlantic region plummeted by as much as 15 degrees Celsius within decades. The advancing forests died back, ice sheets began advancing again, and human populations that had begun to flourish were forced back to survival strategies that their ancestors had used during the depths of the Ice Age. The conventional explanation centers on the collapse of ice dams that had contained massive glacial lakes in North America. When these dams failed, enormous volumes of fresh water flooded into the North Atlantic, disrupting the ocean circulation patterns that distribute heat globally. The sudden influx of cold, fresh water shut down the Gulf Stream and other currents that carry tropical warmth to northern latitudes. But the precision and timing of the Younger Dryas raise questions that natural explanations struggle to address. The cooling began simultaneously across multiple continents, despite the fact that the proposed freshwater flooding affected only North Atlantic circulation. The temperature changes occurred with step function abruptness rather than the gradual transitions typical of natural climate shifts. Most intriguingly, the end of the Younger Dryas was even more sudden than its beginning. Temperatures returned to pre-cooling levels within just a few decades. Recent research has revealed evidence of cosmic impact events that coincide precisely with the beginning of the Younger Dryas. Sediment layers from this period contain elevated concentrations of cosmic impact markers, nanodiamonds, carbon spherules, and platinum anomalies that suggest extraterrestrial origins. These impact signatures appear across multiple continents simultaneously, indicating a coordinated series of cosmic events rather than a single impact. The impact hypothesis suggests that a fragmented comet or asteroid struck Earth's atmosphere and surface in multiple locations, injecting massive amounts of debris into the atmosphere and triggering the return to Ice Age conditions. The geographic distribution of impact evidence correlates with the regions that experienced the most severe cooling, supporting the idea that cosmic impacts provided the trigger for the Younger Dryas cooling. However, the precision and coordination of these apparent impacts raise questions about their natural origin. Cosmic debris from a single fragmented object would be expected to impact randomly across Earth's surface as the planet rotated. Instead, the impact evidence clusters in patterns that seem almost targeted, concentrated in regions where the climatic effects would be maximized, while avoiding areas where indigenous populations might have had the best chance of survival. Archaeological evidence from Younger Dryas sites includes unusual technological artifacts that don't fit the expected material culture of hunter-gatherer societies. Sites like Göbekli Tepe, which began construction during or immediately after the Younger Dryas, demonstrate organizational and technical capabilities that seem inconsistent with populations struggling to survive renewed Ice Age conditions. The sophisticated astronomical knowledge required for the site's construction suggests access to information that transcended immediate survival needs. The Clovis culture of North America, which flourished just before the Younger Dryas, and then disappeared abruptly when cooling began, left behind technological innovations that appeared suddenly in the archaeological record without clear precedents. Their distinctive stone tool technology showed sophisticated understanding of materials, science, and manufacturing techniques that exceeded anything found in earlier or later hunter-gatherer cultures. Biological evidence from the Younger Dryas period includes mass extinction events that affected North American megafauna but left similar species in other continents largely unaffected. The selective nature of these extinctions suggests environmental pressures more specific than general climate cooling. Some researchers have proposed that the cosmic impacts that triggered the Younger Dryas also caused ecological disruptions through atmospheric chemistry changes that affected specific physiological systems. The electromagnetic signatures preserved in Younger Dryas period sediments show anomalies consistent with intense atmospheric electrical activity. These signatures suggest periods of extraordinary aurora activity and electromagnetic storms that would have affected both climate systems and any technological devices operating during this period. The electromagnetic environment might have been sufficiently disrupted to interfere with technological climate management systems. Ocean sediment cores from the Younger Dryas period reveal chemical compositions that do and match expected patterns for natural freshwater flooding events. The isotopic ratios and trace element concentrations suggest multiple sources of unusual water chemistry, including possible contributions from sublimated cosmic ice or chemically modified atmospheric precipitation. The timing of the Younger Dryas correlates, intriguingly, with astronomical phenomena that could have been predicted by advanced astronomical knowledge. The cooling began during a period of specific planetary alignments and solar cycle variations that might have been anticipated by civilizations with sophisticated understanding of celestial mechanics. This correlation suggests that the Younger Dryas might have been a planned event rather than a natural disaster. Ice core evidence from the Younger Dryas shows atmospheric compositions that include unusual concentrations of rare elements and isotopic ratios that don't match either natural background levels or known volcanic sources. These chemical signatures might represent the atmospheric traces of technological activities designed to trigger or maintain the cooling conditions. The end of the Younger Dryas occurred with even greater precision than its beginning. The return to warming conditions happened so suddenly that it appears as a sharp discontinuity in climate proxy records. This abrupt termination suggests active intervention rather than the gradual natural processes that would be expected from the reversal of oceanic circulation disruptions. The Younger Dryas might represent the final test or calibration of climate control technologies before their permanent deactivation. The precise timing and duration, exactly long enough to stress test renewed warming systems without causing permanent damage to recovering ecosystems, suggests deliberate design rather than natural coincidence. Modern climate research has revealed that the atmospheric and oceanic conditions that ended the Younger Dryas established many of the stable patterns that have characterized the entire Holocene period. The precision with which these stable conditions were established suggests technological intervention designed to create optimal climate conditions for the development of human civilization. The Younger Dryas puzzle may ultimately reveal itself as evidence of the final operational phase of ancient climate management technologies. Rather than representing a natural climate disaster, it might mark the last controlled intervention by systems designed to establish and maintain optimal planetary conditions for technological civilization. The precision of its timing, the coordination of its effects, and the perfection of its resolution all point toward technological rather than natural causation, a final adjustment in a planetary engineering program whose ultimate goal was the stable climate that has enabled human technological development throughout recorded history. In the pale light of a sun that seemed perpetually distant, Small bands of humans moved across a landscape transformed by endless winter. The world they knew bore little resemblance to the planet we inhabit today. It was a realm where survival required constant vigilance against cold that could kill within hours, where finding food meant following the migration patterns of creatures as desperate as themselves, and where fire represented the thin barrier between life and death. Picture a family group of perhaps 20 individuals moving across what would one day become the forests of northern Europe, but was then an endless expanse of tundra dotted with stands of hardy pine and birch. Their breath formed clouds in air so cold it burned their lungs, and every step required careful calculation. Twisted ankle or broken bone in this environment could mean death not just for the injured individual, but for the entire group, if they couldn't keep pace with the migration routes that provided their only access to food. Their clothing, constructed from layers of fur and hide, represented technologies refined through thousands of years of trial and error. Each garment was a masterpiece of engineering, designed to trap body heat while allowing enough ventilation to prevent the deadly accumulation of moisture that would freeze against their skin. The construction of a single winter outfit required the hides of multiple animals, processing techniques that took weeks to complete, and sewing skills that could mean the difference between warmth and death. The search for food consumed nearly every waking hour. Plant foods were scarce in the Ice Age environment, limited to hardy berries that survived freezing, inner bark from specific trees, and rare tubers that could be excavated from frozen ground. The majority of nutrition came from hunting massive herbivores that had adapted to Ice Age conditions. Woolly mammoths, woolly rhinoceros, cave bears, and herds of reindeer that migrated seasonally across the frozen landscape. Hunting these creatures required sophisticated understanding of animal behavior, weather patterns, and tool technologies that pushed Stone Age capabilities to their limits. A mammoth hunt was a community enterprise that involved weeks of planning, coordination of multiple hunting parties, and tools designed specifically for bringing down animals that weighed several tons. The failure of a major hunt could mean starvation for the entire group during the long winter months when other food sources were completely unavailable. Fire represented more than simple warmth. It was the technology that made human survival possible in Ice Age conditions. Maintaining fire required constant attention to fuel gathering, understanding of combustion principles that could keep flames alive in sub-zero temperatures, and portable fire-starting technologies that could create flame from materials available in frozen environments. The loss of fire meant death within days, making fire-making knowledge among the most critical survival skills possessed by Ice Age humans. Shelter construction in Ice Age environments demanded architectural understanding that rivaled later civilizations in its sophistication. Ice Age dwellings needed to provide protection from winds that could reach hurricane velocity, insulation sufficient to maintain livable temperatures in extreme cold, and structural stability that could withstand the weight of accumulated snow and ice. Archaeological evidence reveals dwelling structures built from mammoth bones, constructed with engineering principles that distributed weight loads and maximized thermal efficiency. The psychological pressures of Ice Age survival shaped human consciousness in ways that may have influenced our evolutionary development. Living in constant proximity to death, dependent on group cooperation for survival, and faced with environmental challenges that required innovative solutions, Ice Age humans developed mental capabilities that emphasized pattern recognition, long-term planning, and social coordination. The cognitive demands of Ice Age survival may have accelerated human intellectual development in ways that prepared our species for later technological advancement. Social structures during the Ice Age necessarily emphasized collective survival over individual achievement. Resource sharing wasn't altruism, but necessity. The failure of any group member could compromise the survival of all. This led to social organizations that prioritized group knowledge, collective decision-making, and the preservation of survival-critical information through oral traditions that could transmit essential knowledge across generations. The astronomical knowledge developed by Ice Age humans reflects both practical necessity and intellectual achievement that challenges stereotypes about Stone Age capabilities. Survival in Ice Age conditions required precise understanding of seasonal cycles, ability to predict weather patterns months in advance, and navigation capabilities that could guide groups across featureless landscapes during extended migrations. The astronomical alignments found in late Ice Age archaeological sites demonstrate mathematical and observational capabilities that suggest Ice Age humans possessed intellectual resources that exceeded immediate survival requirements. Tool technologies developed during the Ice Age represent some of the most sophisticated stoneworking ever achieved by human cultures. The precision blade production, composite tool construction, and specialized implements found in Ice Age sites demonstrate manufacturing capabilities that required generations of accumulated knowledge and technical refinement. These tools weren't crude survival implements, but precision instruments, designed for specific tasks and manufactured to standards that wouldn't be exceeded until the development of metal technologies. The artistic achievements of Ice Age humans, preserved in cave paintings and portable art objects, reveal psychological and intellectual lives that transcended mere survival. The sophisticated representational techniques, symbolic systems, and aesthetic sensibilities demonstrated in Ice Age art suggest that even under extreme survival pressures, humans maintained cultural and intellectual pursuits that enriched their mental lives beyond immediate physical needs. Migration patterns during the Ice Age required navigational knowledge and organizational capabilities that could coordinate the movement of multiple groups across continental distances. The successful peopling of continents during Ice Age conditions demonstrates logistical and planning capabilities that rival modern expedition management. These migrations weren't desperate flights from adverse conditions, but organized expansions that required sophisticated understanding of geography, resource distribution, and seasonal timing. The preservation of knowledge through oral traditions during the Ice Age may have included information about pre-Ice Age conditions and technologies that challenged later understanding of technological development. Stories preserved through thousands of years of oral transmission might contain encoded information about advanced capabilities that existed before Ice Age conditions made their practical application impossible. Medical knowledge developed during Ice Age conditions included sophisticated understanding of human physiology, herbal medicines effective in extreme environments, and surgical techniques that could address traumatic injuries without modern medical infrastructure. The survival of individuals with healed fractures and evidence of successful medical interventions suggests healthcare capabilities that contradicted the brutal reputation often attributed to Stone Age life. The spiritual and philosophical responses of Ice Age humans to their environment may have shaped religious and philosophical traditions that persist in modified forms today. The direct confrontation with mortality, the dependence on natural forces beyond human control, and the collective struggle for survival created worldviews that emphasized harmony with natural systems and respect for the powers that governed environmental conditions. As Ice Age conditions gradually ended, the accumulated knowledge, technologies, and social organizations developed during the frozen millennia provided the foundation for the rapid cultural development that characterized the early Holocene period. The explosion of human achievement that followed Ice Age termination may have been enabled by capabilities and knowledge systems that had been refined through thousands of years of survival in humanity's most challenging environment. The struggle for survival in the frozen world forged human capabilities that enabled not just survival, but eventual mastery of planetary systems. The descendants of Ice Age survivors possessed intellectual capabilities, technological knowledge, and social organizational skills that had been developed under the most demanding conditions possible. When the ice finally retreated, these capabilities provided the foundation for achievements that would eventually include the development of technologies capable of altering planetary climate systems, perhaps completing a cycle that began with the Ice Age itself. As the great ice sheets began their final retreat, the meltwater that had been locked away for millennia sought new paths to the sea. But the floods that followed Ice Age termination were more than simple drainage events. They were planetary-scale catastrophes that swept away entire landscapes and created geological features that persist today. The global consistency of flood legends suggests that these events were coordinated and massive beyond anything that natural melting alone should have produced. The biblical account of Noah's flood describes waters that covered all the high hills under the whole heaven and persisted for precisely calculated periods before receding according to divine timeline. The specific durations mentioned, 40 days of rain, 150 days of maximum flooding, and gradual recession over predetermined periods, suggest controlled release rather than natural drainage patterns. The precision of these time intervals implies technological management of water release rather than chaotic natural flooding. Similar flood narratives appear in cultures throughout the world with remarkable consistency in their details. The Mesopotamian epic of Gilgamesh describes floods that covered the earth for 6 days and 7 nights before receding suddenly. Hindu texts describe the flood of Manu, which covered the entire earth and required divine intervention to manage its recession. These accounts consistently describe floods that began suddenly, reached impossible heights, and ended with equal abruptness through apparent supernatural intervention. The geological evidence for massive flooding at the end of the Ice Age supports the basic historical accuracy of these legends, but the scope and coordination of the flooding events suggest artificial triggering and management. The Missoula floods, which carved the channeled scablands of Washington state, involved the repeated catastrophic drainage of glacial lakes containing volumes of water that dwarf modern lakes. The precision with which these floods carved specific geological features suggests controlled release rather than random dam failures. The Bonneville flood, which drained ancient Lake Bonneville in Utah, created geological features that indicate water flow rates that seem impossible for natural dam failure events. The flood carved canyons hundreds of feet deep in solid rock within days or weeks, moving boulders the size of houses across hundreds of miles. The energy required for such geological modification exceeds what should have been available from simple gravitational drainage of an Ice Age lake. Marine geological evidence reveals that sea level rises during deglaciation occurred in discrete pulses rather than gradual increases. Meltwater Pulse 1 erased global sea levels by 16 to 24 meters within 400 to 500 years, requiring ice sheet collapse rates that natural warming alone seems insufficient to explain. The synchronization of ice sheet collapse across multiple continents suggests coordinated triggering mechanisms rather than independent response to regional climate changes. The Black Sea deluge hypothesis proposes that the Black Sea was rapidly filled by catastrophic flooding from the Mediterranean approximately 7,600 years ago. This event would have displaced massive populations and created the flood legends that appear in Middle Eastern cultures. However, the precise timing and magnitude of the flooding suggest artificial triggering, possibly the planned release of water barriers that had maintained lower sea levels during the transition from Ice Age to interglacial conditions. The flooding of Doggerland, the land bridge that connected Britain to continental Europe, occurred with sufficient speed to preserve evidence of human settlements on what is now the seafloor. The archaeological remains suggest that the flooding caught populations off guard despite the gradual nature of post-glacial sea level rise. This implies that the final flooding events occurred much more rapidly than the overall trend would predict. Australian Aboriginal flood legends describe catastrophic inundation events that match geological evidence for post-glacial sea level changes around the Australian continent. The specificity of these oral traditions, which include details about specific geographical features now underwater, suggests that Aboriginal cultures preserved accurate memories of flooding events that occurred thousands of years ago. The precision of these memories implies that the flooding was sufficiently dramatic and rapid to create lasting cultural trauma. Native American flood traditions from both Pacific and Atlantic coastal regions describe coordinated flooding events that affected continental interiors as well as coastal areas. The consistency of timing described in these traditions suggests simultaneous flooding across multiple drainage basins, an effect that would require coordinated water release rather than independent natural events. The engineering requirements for managing planetary-scale flooding would have demanded sophisticated understanding of hydraulic systems, structural engineering, and material science. Controlling the release of meltwater from continental ice sheets would have required structures capable of withstanding enormous water pressures and managing flow rates that could carve canyons through solid rock. The precision with which flood legends describe the timing and duration of these events suggests technological management systems rather than natural processes. Archaeological evidence from flood-affected regions includes structures and artifacts that suggest advance warning and preparation for flooding events. Some sites show evidence of systematic removal of valuable objects and organized abandonment rather than panicked evacuation. This preparation implies that some populations possessed advanced knowledge of flood timing and magnitude. The biblical account includes specific technical details about the construction of Noah's Ark that suggests sophisticated understanding of naval architecture and marine engineering. The dimensions and proportions specified would have created a vessel with optimal stability and cargo capacity for survival in severe ocean conditions. The precision of these specifications suggests access to advanced engineering knowledge rather than improvised survival measures. The animals saved in various flood accounts consistently include breeding pairs that would provide optimal genetic diversity for species recovery following global catastrophe. This selective preservation suggests systematic biological conservation programs rather than random animal rescue efforts. The knowledge required for such programs would have demanded sophisticated understanding of genetics and ecology. The post-flood landscape described in various traditions shows evidence of intentional redesign rather than random geological modification. Rivers that changed course, new mountain ranges, and altered coastlines suggest that the flooding was used as an opportunity to modify planetary geography according to planned specifications. This level of geological engineering would have required capabilities far beyond anything achieved by known ancient civilizations. The timing of major flooding events correlates with the construction of megalithic monuments and the development of agricultural civilizations. The flood legends often describe the survivors as receiving advanced knowledge and technologies that enabled rapid cultural development following the catastrophe. This suggests that the flooding served not just as destruction, but as reconstruction, clearing the landscape for planned cultural and technological advancement. Modern hydraulic engineering reveals that managing water flows on the scales described in flood legends would require dam and canal systems comparable to modern large-scale water management projects. The precision with which flood legends describe water level management and controlled recession suggests technological capabilities that rival contemporary hydroengineering. The global coordination required for simultaneous flooding across multiple continents implies communication and control systems that could manage technological operations on planetary scales. The consistency of flood timing described in legends from isolated cultures suggests that these events were centrally coordinated rather than independent regional catastrophes. The Great Flood legends may ultimately represent historical records of the largest geoengineering project ever undertaken, the controlled termination of ice age conditions through managed release of meltwater from continental ice sheets. Rather than representing divine punishment or natural disaster, these floods might mark the successful completion of a planetary climate management program designed to establish optimal conditions for technological civilization. The precision, coordination, and ultimate beneficence of these events suggest technological intervention aimed at creating the stable interglacial conditions that have enabled human, cultural, and technological development throughout recorded history. The concept of energy as a weapon extends far beyond conventional explosives or directed energy beams into the realm of planetary-scale environmental manipulation. When energy systems capable of altering fundamental atmospheric and oceanic processes are considered as potential weapons, the scale of possible destruction and the precision of possible control reaches levels that could reshape entire continents and alter global climate patterns for millennia. Atmospheric energy manipulation offers multiple pathways for weaponizing planetary systems. The atmosphere contains enormous amounts of latent energy in the form of water vapor, pressure differentials, and thermal gradients. Advanced understanding of atmospheric physics could enable technologies capable of triggering massive energy releases through relatively small interventions in atmospheric chemistry or dynamics. Consider the energy contained in a single major storm system. A typical hurricane releases energy equivalent to hundreds of nuclear weapons over its lifetime, generated through natural atmospheric processes that convert thermal energy into kinetic energy through water phase transitions. A civilization with advanced atmospheric manipulation capabilities could theoretically trigger or enhance such storm systems, directing their paths and intensifying their effects to target specific geographic regions. Ionospheric manipulation represents another approach to atmospheric energy weaponization. The ionosphere contains vast amounts of electrical energy generated by solar radiation interacting with atmospheric gases. Technologies capable of triggering controlled releases of this energy could create electromagnetic pulses, atmospheric heating events, or electrical phenomena that could affect both technological systems and biological processes over continental areas. The albedo modification approach to energy weaponization involves altering the reflective properties of Earth's surface or atmosphere to change energy absorption patterns. Reducing surface albedo would increase energy absorption and cause regional heating, while increasing albedo through reflective aerosols or surface modifications could cause regional cooling. Such modifications could be precisely targeted to affect specific climate zones while leaving others unaffected. Ocean thermal energy represents one of the largest energy reservoirs on the planet. The temperature differential between surface and deep ocean waters contains enormous amounts of potential energy that could theoretically be released through technologies that disrupt natural thermal stratification, triggering massive upwelling events or artificially modifying ocean circulation patterns, could redistribute thermal energy on scales sufficient to alter global climate patterns. Geothermal energy weaponization could involve triggering volcanic eruptions or enhance geothermal activity through technologies that destabilize underground magma chambers or create artificial pathways for geothermal energy release. The energy content of major volcanic eruptions exceeds nuclear weapons by orders of magnitude, and the atmospheric effects of large eruptions can cause global climate cooling for years or decades. Electromagnetic energy systems offer possibilities for both direct and indirect weaponization. Powerful electromagnetic fields could disrupt technological systems, interfere with biological processes, or trigger atmospheric phenomena through ionospheric modification. The energy requirements for such systems would be enormous, but the effects could be precisely controlled and targeted to specific geographic areas or technological systems. Solar energy modification represents perhaps the ultimate form of energy weaponization technologies capable of altering the amount of solar radiation reaching Earth's surface. This could involve space-based systems that block or redirect solar radiation, atmospheric modifications that change radiation absorption or reflection, or even more exotic approaches involving manipulation of solar output itself. The precision required for energy weaponization on planetary scales would demand sophisticated targeting and control systems capable of managing complex feedback loops and avoiding unintended consequences. Natural energy systems are interconnected in ways that make precise control extremely challenging. Small modifications in one system can trigger cascading effects throughout interconnected planetary systems. The timescales involved in energy weaponization create both advantages and disadvantages for potential users. Some energy-based weapons could produce immediate effects, while others might require years or decades to fully manifest their impacts. This delayed response could provide strategic advantages for civilizations capable of long-term planning, but would also make such weapons difficult to control or reverse if their effects exceeded intended parameters. The defensive implications of energy weaponization are as significant as the offensive possibilities. Civilizations capable of energy-based attacks would necessarily possess the knowledge and technology to defend against such attacks. This could create strategic balance scenarios where multiple civilizations possessed energy weapons but were deterred from using them by mutual vulnerability. The energy sources required for planetary-scale weaponization would necessarily involve technologies beyond anything currently available to human civilization. Controlling atmospheric or oceanic energy systems would require power generation and distribution capabilities that could manage energy flows equivalent to significant fractions of total solar energy input to Earth-S systems. Historical precedents for energy weaponization may exist in geological and climate records that have been misinterpreted as natural phenomena. Sudden climate changes, mass extinction events, and geological formations that seem inconsistent with known natural processes might represent evidence of ancient energy weapons, whose use shaped planetary history in ways we don't yet recognize. The Ice Age itself could represent the ultimate example of energy weaponization, the use of planetary energy systems to create global climate conditions that made most of Earth's surface uninhabitable for advanced civilizations. The precision and longevity of Ice Age conditions suggest control systems capable of maintaining artificial climate patterns for tens of thousands of years. The reversibility of energy weaponization depends on maintaining access to the control systems that manage planetary energy flows. If energy weapons operate by triggering natural feedback loops, they might continue their effects indefinitely without ongoing control. Alternatively, sophisticated control systems might enable precise management of energy weapon effects, including their reversal when strategic objectives have been achieved. Modern climate research has revealed that planetary energy systems include numerous tipping points where small changes can trigger large-scale irreversible effects. Knowledge of these tipping points could enable energy weapons of unprecedented power and precision technologies, capable of triggering permanent changes in planetary systems through relatively modest energy inputs. The ethics of energy weaponization raise profound questions about the appropriate use of planetary-scale technologies. Weapons capable of altering global climate patterns or atmospheric composition would affect not just target civilizations, but all life on Earth. The decision to use such weapons would necessarily involve considerations of planetary stewardship and the rights of future generations. The Ice Age may serve as both historical example and warning about the ultimate consequences of energy weaponization. If advanced civilizations once possessed the capability to alter planetary energy systems, the frozen millennia that followed might represent the aftermath of conflicts fought with weapons whose power exceeded the wisdom of their users. The gradual warming that ended the Ice Age might mark natural climate recovery, but the eventual restoration of planetary energy balance by systems designed to prevent permanent damage to Earth's habitability. Beyond terrestrial geoengineering and atmospheric manipulation lies the most audacious possibility of all that advanced ancient civilizations possessed the capability to alter Earth's astronomical relationships themselves. This would involve technologies capable of modifying planetary orbits, adjusting axial tilt, or even repositioning Earth within the solar system to create the precise celestial mechanics that triggered and maintained Ice Age conditions. Earth's orbital characteristics determine the fundamental parameters of our planet's climate system. The Milankovitch cycle's variations in orbital eccentricity, axial tilt, and precession control the distribution of solar energy, reaching Earth's surface over timescales of tens of thousands of years. Small modifications in these orbital parameters could trigger climate changes far more dramatic than any terrestrial geoengineering project. Consider the energy requirements for orbital modification. While the forces involved are enormous by human standards, they operate over cosmic timescales that could make gradual orbital adjustments feasible for sufficiently advanced civilizations. The kinetic energy needed to alter Earth's orbit could theoretically be supplied through technologies that harness gravitational forces, solar energy, or even more exotic energy sources. Gravitational manipulation represents one approach to astronomical engineering. Advanced understanding of gravitational physics might enable technologies capable of creating artificial gravitational fields or manipulating existing gravitational relationships. Such technologies could potentially alter the gravitational interactions between Earth and other celestial bodies in ways that would gradually modify orbital characteristics. The asteroid belt contains enormous amounts of material that could theoretically be redirected to alter planetary orbits through gravitational perturbations. Advanced spacefaring civilizations might have developed the capability to orchestrate asteroid movements that would create precisely calculated gravitational influences on planetary orbits over geological timescales. Jupiter's gravitational influence plays a crucial role in determining Earth's orbital stability and the frequency of comet impacts. Technologies capable of modifying Jupiter's orbit or mass distribution could indirectly affect Earth's orbital characteristics and exposure to cosmic impacts. Such modifications might be more feasible than direct manipulation of Earth's orbit while achieving similar climate control objectives. Axial tilt modification offers another approach to astronomical climate control. Earth's current axial tilt, approximately 23.5 degrees, determines the intensity of seasonal variations and the distribution of solar energy between hemispheres. Technologies capable of altering axial tilt could create dramatic changes in seasonal patterns and regional climate conditions. The Moon plays a significant role in stabilizing Earth's axial tilt and creating tidal forces that influence oceanic circulation. Modifications to lunar orbit or mass could affect both tidal patterns and axial stability in ways that would alter global climate patterns. Advanced civilizations might have found lunar manipulation more feasible than direct modification of Earth's astronomical characteristics. Solar system scale engineering projects could involve modifications to multiple planetary bodies designed to create specific gravitational configurations that would optimize Earth's climate conditions. This could include repositioning asteroids, modifying planetary orbits, or even constructing artificial celestial bodies designed to provide precise gravitational influences. The precision required for astronomical climate control would demand predictive capabilities that could model complex gravitational interactions over geological timescales. Such modeling would require computational resources and mathematical sophistication that might exceed current human capabilities, but could be achievable for civilizations with advanced mathematical and technological development. The timescales involved in astronomical engineering create both opportunities and challenges for climate control applications. Orbital modifications might take thousands of years to fully manifest their climate effects, but once established, they could maintain those effects indefinitely without requiring ongoing energy input or technological maintenance. Evidence for artificial orbital modifications might be preserved in astronomical records that extend beyond human observation periods. Careful analysis of planetary orbital characteristics and their historical variations might reveal signatures of artificial intervention that have been misinterpreted as natural celestial mechanics. The geological record contains evidence of periodic events that correlate with astronomical cycles. But some of these correlations show patterns that seem too precise for natural orbital variations. Ice age timing, mass extinction events, and major geological transitions often align with astronomical cycles in ways that suggest artificial enhancement of natural celestial influences. Ancient astronomical knowledge preserved in megalithic monuments and historical texts often demonstrates understanding of celestial mechanics that seems inconsistent with the supposed technological capabilities of their builders. This knowledge might represent inherited understanding of artificial astronomical systems rather than purely observational astronomy. The construction of astronomical monuments like Stonehenge, the pyramids of Giza, and various other megalithic sites demonstrate sophisticated understanding of celestial mechanics and precise astronomical alignments. These monuments might serve as operational interfaces for astronomical engineering systems rather than purely ceremonial or observational structures. Tidal patterns preserved in geological formations show historical variations that don't match current lunar orbital characteristics. These variations might indicate that lunar orbit has been artificially modified in the past, with consequences for both tidal forces and Earth's axial stability that contributed to ice age climate conditions. The stability of Earth's orbit within the solar system's habitable zone represents a remarkably precise balance that enables liquid water and moderate climate conditions. The probability of achieving such precise orbital characteristics through purely natural processes has been questioned by some astronomers, suggesting possible artificial optimization of Earth's astronomical position. Electromagnetic effects associated with planetary motion and rotation could potentially be manipulated through technologies that alter planetary magnetic fields or electromagnetic interactions with solar radiation. Such modifications might affect atmospheric behavior and climate patterns through mechanisms that don't require direct gravitational manipulation. The synchronization of ice age timing with specific astronomical configurations suggests that natural orbital cycles may have been artificially enhanced or triggered by technologies that could amplify the climate effects of celestial mechanical variations. This could have enabled relatively modest astronomical modifications to produce dramatic climate changes. Modern space technology research has begun to investigate concepts for asteroid redirection and orbital modification that could serve as precursors to more advanced astronomical engineering capabilities. These current research directions might represent early steps toward rediscovering technologies that were mastered by ancient civilizations. The reversibility of astronomical modifications presents both opportunities and challenges for civilizations possessing such capabilities. While orbital changes could theoretically be reversed through appropriate technological interventions, the timescales and energy requirements involved would make such reversals major undertakings that might exceed the capabilities of civilizations that had experienced technological decline. The Ice Age might represent the consequences of astronomical engineering projects that achieved their intended climate control objectives, but were maintained longer than originally planned due to the collapse of the civilizations that created them. The gradual warming that ended the Ice Age could mark the eventual restoration of Earth's natural orbital characteristics as artificial astronomical systems finally cease their operations. The astronomical angle suggests that Ice Age climate control might have been achieved through modifications to the fundamental celestial mechanics that govern Earth's relationship with the Sun and other planetary bodies. Such capabilities would represent the ultimate expression of technological civilization, a power to engineer not just planetary systems, but the astronomical relationships that determine planetary conditions. If such technologies existed in the past, their legacy might be preserved not only in geological and climate records, but in the current astronomical characteristics that continue to influence Earth's climate and habitability. 2.5 miles beneath the Antarctic ice, sealed away from the surface world for approximately 15 million years, lies Lake Vostok, a body of water larger than Lake Ontario. Hidden in complete darkness under pressures that would crush surface-dwelling organisms. This subglacial lake, discovered through ice-penetrating radar in the 1990s, has become the focus of intense scientific speculation and rumor, with some researchers suggesting it might contain more than just ancient microorganisms in pristine water. The first anomaly that drew attention was magnetic. Satellite measurements revealed magnetic field variations above Lake Vostok that don't match expected patterns for subglacial water. The magnetic anomalies are too strong and too geometrically organized to result from natural geological formations. They suggest the presence of metallic structures or materials with electromagnetic properties that should not exist in a natural subglacial environment. When Russian drilling teams finally penetrated the ice above Lake Vostok in 2012, they encountered unexpected resistance at depths that should have been liquid water. Drill core analysis revealed materials with unusual properties, ice formations that contained metallic inclusions and chemical compositions that didn't match, expected signatures for ancient atmospheric gases trapped in natural ice. The biological discoveries added another layer of mystery. While researchers expected to find extremophile microorganisms adapted to the lake's unique conditions, some of the biological material recovered showed genetic characteristics that didn't match any known evolutionary lineages. The metabolic pathways of these organisms suggested energy sources beyond what should be available in a sealed subglacial environment. Acoustic surveys of the lake revealed bottom topography that includes geometric formations, inconsistent with natural lake bed geology. The formations show right angles, parallel lines, and symmetrical structures that resemble artificial construction rather than geological processes. The acoustic signatures suggest hollow spaces and structural complexities that don't match typical lake sediment patterns. Temperature measurements within the lake revealed thermal anomalies that suggest internal heat, sources beyond what geothermal activity should provide. The heat distribution patterns show localized hotspots and thermal gradients that resemble technological heat generation rather than natural geothermal processes. Some areas of the lake maintain temperatures significantly higher than the surrounding environment without apparent geological heat sources. Chemical analysis of lake water samples showed isotopic ratios and trace element concentrations that don't match expected compositions for ancient atmospheric precipitation or geological processes. The water contains unusual concentrations of rare elements and synthetic-seeming compounds that suggest artificial chemical processes rather than natural water chemistry evolution. Electromagnetic monitoring of the lake region has detected radio frequency emissions that pulse with regular periodicity rather than the random electromagnetic noise expected from natural sources. The frequency patterns and timing suggest technological sources rather than natural electromagnetic phenomena associated with geological or atmospheric processes. Seismic surveys have revealed structural formations beneath the lake that extend deep into the bedrock. These formations show characteristics consistent with constructed rather than natural underground spaces. The geometric precision and scale of these structures suggest engineering capabilities that exceed what any known ancient civilization should have possessed. The preservation conditions within Lake Vostok create an environment where technological artifacts could remain functional for millions of years. The combination of constant temperature, chemical stability, and protection from cosmic radiation would provide ideal storage conditions for advanced materials and electronic systems. Any technological installations placed in the lake environment would be naturally preserved and protected from surface detection. Recent drilling operations have encountered unusual electrical phenomena when approaching the lake interface. Equipment failures and electromagnetic interference have occurred with patterns that suggest artificial electrical fields rather than natural electromagnetic effects. Some drilling attempts have been abandoned due to equipment malfunctions that seem to indicate active electromagnetic countermeasures. Ground-penetrating radar surveys of the broader Antarctic region have revealed that Lake Vostok may be connected to a network of subglacial water bodies through underground channels. This interconnected system could serve as a continent-wide infrastructure network if it includes artificial components designed to coordinate activities across multiple sites. The timing of Lake Vostok's formation correlates with the beginning of major Antarctic ice sheet development and global ice age conditions. If technological installations were placed in the lake system during warmer periods, their activation could have contributed to the continental cooling that initiated Antarctic glaciation and broader ice age climate conditions. Gravitational anomalies detected over the Lake Vostok region suggest mass concentrations that do and match expected densities for liquid water and natural geological formations. The gravitational signatures indicate dense, artificially arranged materials and configurations that wouldn't occur through natural processes. The strategic location of Lake Vostok at the South Pole provides optimal positioning for technologies designed to influence global atmospheric and electromagnetic systems. Installations at the South Pole would be positioned to affect both atmospheric circulation patterns and Earth as magnetic field in ways that could influence global climate conditions. International agreements restricting access to Lake Vostok have limited comprehensive exploration of the lake's contents and structure. While these restrictions are officially justified by environmental protection concerns, they also prevent independent verification of discoveries and limit public access to information about the lake's unusual characteristics. Modern technology demonstrations have shown that advanced materials and systems can operate reliably in extreme cold and high-pressure environments, similar to Lake Vostok conditions. This suggests that technological installations could theoretically function in the lake environment for extended periods, potentially including systems designed for climate manipulation or environmental monitoring. The biological contamination protocols required for Lake Vostok exploration have revealed that the lake environment is more chemically complex than initially expected. The sterilization requirements and contamination prevention measures suggest that the lake contains chemical and biological components that could be compromised by surface contamination, possibly including artificial biological or chemical systems. Lake Vostok might represent more than a natural subglacial lake. It could be a preserved technological installation designed to influence Antarctic and global climate systems. The magnetic anomalies, unusual biology, geometric formations, and electromagnetic signatures all suggest the possibility of artificial systems preserved in the lake's unique environment. As Antarctic ice continues to change due to modern climate warming, the installations beneath the ice might become more accessible, potentially revealing technologies that could fundamentally alter our understanding of both ancient capabilities and current climate management possibilities. The secret of Lake Vostok may ultimately prove to be that it serves as more than a geological curiosity. It might be a functional component of the climate control systems that created and maintained ice age conditions. The lake's preservation beneath Antarctic ice may have been intentionally designed to protect technological installations until a time when they might be needed again, or when human technological development reached sufficient sophistication to understand and utilize ancient climate management capabilities. In the spaces between recorded history and archaeological evidence, between the retreat of ice sheets and the rise of known civilizations, lie tantalizing hints that some remnants of advanced Ice Age civilizations may have survived the great climate transitions. These survivors, whether human, hybrid, or something else entirely, might have preserved fragments of the knowledge and technology that once controlled planetary climate systems. The megalithic monuments that appeared suddenly after ice age termination demonstrate construction capabilities and astronomical knowledge that seem inconsistent with the supposed technological development of post-glacial hunter-gatherer societies. Göbekli Tepe, constructed beginning around 11,600 years ago, required organizational capabilities specialized tool technologies, and sophisticated understanding of engineering principles that exceeded anything attributed to Neolithic cultures. The precision of astronomical alignments in these monuments suggests not just observational astronomy, but practical knowledge of celestial mechanics that could only have been developed through long-term technological application. The builders of these sites possessed mathematical capabilities, surveying techniques, and construction technologies that imply inheritance from more advanced predecessors rather than independent development by primitive societies. Archaeological evidence from various sites around the world includes artifacts and technological remnants that do and fit established chronologies of human technological development. The Antikythera mechanism, precision-manufactured metal objects found in geological contexts that predate known metallurgy, and construction techniques that demonstrate understanding of advanced engineering principles, all suggest the persistence of technological knowledge beyond its supposed historical origins. Genetic studies of human populations have revealed ancestry patterns that include contributions from unknown human or human-like populations that don't match established models of human migration and development. Some genetic lineages show characteristics that suggest hybridization with populations possessing significantly different evolutionary histories, possibly including groups that had adapted to Ice Age conditions over much longer periods. Mythological traditions from cultures around the world describe interactions with beings possessing advanced knowledge and capabilities that exceeded normal human limitations. These beings are often described as survivors from previous ages, possessors of ancient wisdom, or guardians of technological knowledge that could influence natural systems, including weather and climate. The Anunnaki of Mesopotamian tradition, the Watchers of Hebrew texts, the Virakaka of Indian cultures, and similar beings described in various mythologies share characteristics that suggest they might represent cultural memories of actual interactions with technologically advanced survivors from pre-civilizational periods. Their descriptions often include specific technological capabilities related to atmospheric manipulation, agricultural enhancement, and engineering projects. Oral traditions preserved by indigenous cultures often include accounts of ancient ones or first people who possessed knowledge and capabilities that were lost during great catastrophes, but were partially preserved and transmitted to later generations. These traditions frequently describe technologies related to weather control, agricultural enhancement, and construction techniques that enabled the creation of sophisticated infrastructure. The sudden appearance of agricultural techniques, astronomical knowledge, and urban planning capabilities in various regions around the world suggests transmission of advanced knowledge rather than independent development. The precision and sophistication of early agricultural systems, astronomical observatories, and urban layouts imply access to information systems and technological capabilities that exceeded what should have been available to recently nomadic populations. Linguistic analysis has revealed that certain technical vocabularies and mathematical concepts appear simultaneously in cultures that should have had no contact with each other. The distribution of advanced mathematical knowledge, astronomical terminology, and engineering concepts suggests common sources that might represent preserved knowledge from earlier technological civilizations. Isolated human populations in various parts of the world have preserved technological capabilities and knowledge systems that exceed what would be expected from their supposed isolation and primitive conditions. Some groups demonstrate understanding of advanced metallurgy, precision construction techniques, and natural science knowledge that suggests inheritance from more technologically sophisticated ancestors. The establishment of mystery schools, secret societies, and esoteric traditions throughout recorded history often centers around the preservation and transmission of ancient knowledge related to natural forces and technological capabilities. These traditions frequently claim inheritance from prehistoric civilizations and include knowledge related to atmospheric manipulation, geological engineering, and other large-scale technological applications. Underground installations and tunnel systems found in various parts of the world show construction characteristics that exceed the capabilities attributed to their supposed builders. These systems often include precision-engineered ventilation, water management, and structural features that suggest advanced understanding of engineering principles and access to sophisticated construction technologies. Biological evidence from various archaeological sites includes remains of organisms that show genetic modifications or adaptive characteristics that seem inconsistent with natural evolutionary processes. Some specimens show evidence of artificial genetic manipulation or selective breeding programs that would require sophisticated understanding of biological systems and long-term population management. The preservation of astronomical knowledge through periods of supposed technological decline suggests the existence of groups dedicated to maintaining and transmitting advanced scientific knowledge across cultural transitions. The accuracy and sophistication of astronomical knowledge preserved in various traditions implies continuous observation and calculation, capabilities that would require technological infrastructure and specialized expertise. Technological artifacts found in geological contexts that predate known technological civilizations continue to challenge established chronologies of human development. These objects often show manufacturing precision and material properties that exceed the capabilities attributed to their supposed time periods, suggesting either much earlier technological development or preservation of artifacts from advanced predecessors. Modern genetic analysis has revealed that human populations in various regions carry genetic markers that suggest exposure to environmental conditions or technological influences that do and match established models of human evolutionary history. Some populations show genetic adaptations that seem specifically designed for survival in technologically modified environments or exposure to artificial environmental influences. The strategic locations of many ancient sites suggest they were positioned according to comprehensive understanding of global geographical, climatic, and geological systems. The placement of major monuments and installations often optimizes their potential influence on regional environmental conditions in ways that would require sophisticated modeling of planetary systems. Energy detection at various ancient sites reveals electromagnetic, gravitational, or other energy signatures that suggest the presence of technologies that remain partially functional despite their supposed age. These energy signatures often show patterns consistent with artificial rather than natural sources, and sometimes respond to external stimuli in ways that suggest automated or programmable systems. The survivors of the Hidden Age might not represent a single group or species, but rather multiple populations that preserve different aspects of advanced Ice Age technologies. Some might have specialized in astronomical knowledge, others in biological engineering, and still others in atmospheric or geological manipulation. The fragmented nature of preserved advanced knowledge might reflect the distribution of specialized knowledge among different survivor populations. Modern encounters with unexplained phenomena, including UFO sightings, unexplained technological capabilities, and demonstrations of advanced knowledge by unknown groups, might represent evidence that technologically advanced survivors of ancient civilizations continue to exist in hidden or isolated conditions. These groups might possess climate control technologies and maintain monitoring or intervention capabilities related to planetary environmental management. The survivors of the Hidden Age represent the possibility that humanity is not the first technologically advanced species to inhabit Earth, and that remnants of earlier technological civilizations continue to influence planetary development through preserved knowledge, hidden installations, or direct intervention. The climate stability that has enabled human technological development might itself be maintained by these survivors, who possess understanding of the climate, control systems that once created Ice Age conditions and could potentially recreate them if current climate management proves inadequate. At the heart of the Ice Age mystery lies a profound moral question that challenges our understanding of both technological capability and ethical responsibility. If advanced civilizations possess the power to alter planetary climate systems, the motivation behind creating Ice Age conditions becomes as important as the technical methods they employed. Were the frozen millennia intended as an act of preservation, a weapon of destruction, or something else entirely? The preservation hypothesis suggests that Ice Age conditions were deliberately created to protect Earth as biosphere during a period of existential threat. Perhaps the technologically advanced civilization responsible for climate manipulation faced an extinction-level event, cosmic impact, ecological collapse, or civilizational warfare that could only be survived by fundamentally altering planetary conditions to create a protective frozen state. Under this interpretation, Ice Age conditions served as a planetary-scale preservation system, similar to placing biological samples in cryogenic storage. The reduced metabolic rates, decreased geological activity, and simplified ecological systems of Ice Age, Earth might have provided optimal conditions for preserving both biological diversity and technological infrastructure through a period of catastrophic danger. The timing of Ice Age initiation supports this preservation hypothesis. The Ice Age began during a period of apparent ecological stress and potential civilizational conflict. As suggested by the sudden disappearance of large fauna and the apparent collapse of whatever advanced civilizations might have existed during the preceding warmer period, the Ice Age might have been implemented as an emergency measure to prevent complete planetary devastation. The selective nature of Ice Age preservation also supports this interpretation. While most of Earth's surface became uninhabitable, certain regions protected valleys, geothermally active areas, and strategically located refugia maintained conditions suitable for survival of both biological species and potentially human populations. This selective preservation suggests deliberate design rather than indiscriminate destruction. However, the destruction hypothesis cannot be dismissed. The scale and duration of Ice Age conditions caused massive extinction events, eliminated entire ecosystems, and rendered most of Earth's surface uninhabitable for tens of thousands of years. If this was intentional, it represents one of the most comprehensive acts of planetary-scale destruction in Earth's history. The targeting of Ice Age effects supports the destruction interpretation. The regions most severely affected by glaciation were precisely those areas where advanced civilizations would have been most likely to develop. Temperate zones with moderate climates, abundant resources, and geographic features suitable for large-scale agriculture and urban development. The ice sheets systematically eliminated the environmental conditions that enabled technological civilization. The duration of Ice Age conditions suggests a level of determination that exceeds what would be necessary for mere preservation. If the goal was protection during a temporary crisis, the Ice Age could have been designed to last centuries or millennia, rather than the 100,000 years that characterized full glacial conditions. The extended duration implies either loss of control over the climate manipulation systems or intentional long-term elimination of technological competitors. The warfare hypothesis presents Ice Age conditions as the ultimate expression of conflict between technologically advanced civilizations. Rather than conventional warfare fought with weapons that destroy armies or cities, climate manipulation represents warfare that destroys entire civilizations by eliminating the environmental conditions that support technological development. Such climate warfare would possess several strategic advantages over conventional weapons. It would be difficult to defend against, require minimal ongoing maintenance once initiated, and would eliminate opposing civilizations so completely that they could never recover to threaten the victors. The apparent thoroughness of Ice Age civilization elimination suggests weaponized rather than accidental climate manipulation. The lack of obvious victors from Ice Age conditions challenges the simple warfare hypothesis. If the Ice Age was created as a weapon, the civilization that deployed it apparently failed to survive to enjoy the benefits of victory. This suggests either mutual destruction loss of control over climate weapons, or successful retaliation that eliminated all parties to the original conflict. The experiment hypothesis proposes that Ice Age conditions were created as a controlled test of planetary climate management capabilities. An advanced civilization might have attempted to demonstrate or refine their climate control technologies through large-scale planetary modification, intending to reverse the effects once their experiments were complete. This interpretation is supported by the apparent precision and control demonstrated throughout Ice Age cycles. The regular patterns of glacial advance and retreat, the selective preservation of certain species and regions, and the eventual restoration of interglacial conditions all suggest systematic testing of climate manipulation parameters, rather than uncontrolled environmental collapse. The failure to properly reverse experimental conditions might explain why Ice Age conditions persisted far longer than intended. Loss of technological capability, civilizational collapse, or unforeseen complications in climate feedback systems might have prevented the experimental civilization from restoring normal planetary conditions as originally planned. The salvation hypothesis suggests that Ice Age conditions were created not to destroy existing civilizations, but to prepare Earth for future ones. The climate manipulation might have been designed to reset planetary, ecological, and geological systems to optimal conditions for supporting advanced technological development by successor civilizations. Under this interpretation, the Ice Age served as a planetary restoration process, clearing accumulated environmental damage from previous civilizations and establishing the stable interglacial conditions that have enabled human technological development. The preserved biological diversity, renewed soil systems, and climatic stability of the Holocene might represent the intended outcome of Ice Age engineering. The timing of Ice Age termination correlates with the emergence of human technological capability, suggesting that the climate restoration was programmed to conclude when human development reached sufficient sophistication to benefit from optimal planetary conditions. This timing might reflect advanced planning by predecessor civilizations that anticipated the eventual rise of human technology. The moral complexity of these possibilities extends beyond simple categories of good and evil into questions of planetary stewardship and intergenerational responsibility. A civilization possessing climate manipulation capabilities would face ethical dilemmas that have no precedent in human experience, decisions whose consequences would affect all life on Earth for geological timescales. The preservation of human populations during Ice Age conditions suggests that whatever civilization controlled climate manipulation made conscious decisions about which species and populations would survive the transition. The factors that determined these decisions, genetic diversity, adaptive potential, technological promise, or other criteria, remain unknown, but represent value judgments of enormous consequence. Modern climate change research has revealed that human technological civilization exists within a narrow range of planetary conditions that could be easily disrupted by relatively small changes in atmospheric composition or oceanic circulation. The stability of Holocene climate conditions might represent not natural equilibrium, but continued management by climate control systems that remain operational from the Ice Age period. If ancient climate management systems continue to influence current planetary conditions, humanity might be living within the ongoing consequences of decisions made by prehistoric civilizations. Our current climate stability, agricultural productivity, and technological development might all depend on the continued operation of systems whose creators had their own motivations and objectives for planetary management. The ultimate question of intention, whether Ice Age creators meant to save or destroy, be less important than the question of current responsibility. If humanity has inherited a planet whose climate is artificially managed, we face the choice of learning to operate these systems ourselves, or risking the consequences of their eventual failure or termination. The Ice Age may represent both salvation and destruction, depending on perspective and time frame. What appeared as destruction to contemporary civilizations might have been preservation for future ones. What seemed like warfare might have been restoration. The frozen millennia might have served purposes that encompassed multiple objectives, clearing the way for new civilizations while preserving the biological and technological heritage that would enable their development. As humanity develops its own climate management capabilities, we approach the same moral crossroads faced by our hypothetical predecessors. The power to alter planetary climate systems brings responsibilities that extend far beyond immediate human interests to encompass all life on Earth and all future generations. The Ice Age may serve as both warning and instruction about the ultimate consequences of wielding such power and the profound questions about intention and responsibility that accompany the capability to reshape the conditions of planetary life itself. Across the planet, scattered like breadcrumbs from a civilization lost to time, stand monuments of stone that seem to whisper secrets of the frozen ages. These megalithic structures, constructed with precision that challenges our understanding of ancient capabilities, may represent more than ceremonial sites or astronomical observatories. They might be encoded warnings, instruction manuals, or even functional components of the very climate control systems that once reshaped our world. Stonehenge rises from the Salisbury Plain like a calculator built for giants, its trilithons arranged with mathematical precision that speaks to purposes beyond simple sun worship. The monument's alignment with celestial events extends far beyond basic calendar keeping to encompass complex astronomical relationships that would only be relevant for civilizations capable of long-term climate planning. The heel stone's alignment with summer solstice sunrise might mark not just seasonal celebration, but operational parameters for climate management systems that required precise celestial timing. The recent discovery of underground chambers and tunnel systems beneath Stonehenge reveals architectural complexity that exceeds what surface observations suggest. Ground-penetrating radar has mapped extensive subterranean structures that show geometric precision and engineering sophistication inconsistent with Neolithic construction capabilities. These underground installations might represent the functional components of technological systems, whose surface monuments served as operational interfaces or astronomical calculators. The Great Pyramid of Giza demonstrates construction precision that approaches modern machine tolerances, with base measurements accurate to within millimeters and orientation aligned to true north within 3/60th of a degree. The internal chamber system includes ventilation shafts, aligned with specific stars and mathematical relationships encoded in dimensional proportions that suggest purposes beyond burial monument construction. The pyramid's position at the exact center of Earth's land masses cannot be coincidental. This geographical precision suggests global surveying capabilities, an understanding of planetary geography that exceeded what conventional archaeology attributes to ancient civilizations. If the pyramid served as a central coordination point for global climate management systems, its position would be optimal for communicating with installations worldwide. Göbekli Tepe, predating Stonehenge by thousands of years, presents perhaps the most direct challenge to conventional understanding of post-Ice Age technological capabilities. The site's massive stone pillars, carved with sophisticated symbolic systems and arranged in complex geometric patterns, required organizational capabilities and construction. Technologies that seem impossible for hunter-gatherer societies recently emerged from Ice Age conditions. The timing of Göbekli Tepe's construction, beginning just as Ice Age conditions were ending, suggests it might represent emergency preservation of essential knowledge by survivors of more advanced Ice Age civilizations. The complex symbolic systems carved into the pillars might encode technical information about climate manipulation systems, astronomical relationships, or operational procedures for technological installations. The Karnak alignments in Brittany stretch for kilometers across the landscape in geometric patterns that serve no obvious ceremonial or astronomical purpose. The precision of stone placement and the mathematical relationships between different Alignment sections suggest surveying and construction capabilities that required sophisticated understanding of geometry and engineering principles. Recent research has revealed that the Karnak stones are positioned along geological fault lines and areas of unusual electromagnetic activity. If the alignments were designed to interact with natural electromagnetic fields or geological energy systems, they might represent components of larger technological installations designed to influence atmospheric or geological processes. Newgrange, with its precisely aligned passage tomb that admits sunlight only during winter solstice, demonstrates astronomical knowledge and construction precision that seems excessive for simple ceremonial purposes. The monument's corbelled roof, constructed without mortar, has remained watertight for over 5,000 years, using engineering techniques that modern architects struggle to replicate. The waterproofing system at Newgrange includes channels and drainage systems that suggest understanding of hydrology and material science that exceeded what should have been available to Neolithic builders. If the monument served purposes beyond ceremony, perhaps as a precisely controlled environment for technological equipment, the sophisticated environmental controls would be necessary for operational rather than symbolic reasons. The Easter Island statues, or moai, present mysteries that extend beyond their famous faces to encompass transportation and construction techniques that required sophisticated understanding of engineering principles. Recent excavations have revealed that many statues have bodies buried beneath accumulated soil, and that the monuments include complex internal chamber systems. The strategic positioning of moai around Easter Island's perimeter suggests they might have served as components of a monitoring or communication system rather than simple ceremonial objects. The statue's positions optimize coverage of ocean approaches and celestial views in ways that would be valuable for navigation, communication, or environmental monitoring purposes. Puma Punku in Bolivia demonstrates stone cutting and fitting precision that approaches modern machine shop tolerances. The interlocking stone blocks show evidence of cutting techniques that could produce perfectly straight edges, precise angles, and complex geometric shapes that would challenge contemporary stoneworkers using power tools. The high-altitude location of Puma Punku provides optimal positioning for astronomical observation and radio communication, but also presents construction challenges that make the site's existence even more remarkable. The effort required to transport massive stone blocks to such remote locations suggests purposes that exceeded normal ceremonial or residential needs. The Antikythera mechanism, while not architecture, represents preserved evidence of sophisticated mechanical calculation capabilities that suggest the existence of technological traditions extending far beyond its construction date. The device's ability to calculate complex astronomical relationships and predict celestial events demonstrates mathematical and engineering knowledge that challenges conventional understanding of ancient technological capabilities. The precision of the Antikythera mechanism, S-gear ratios, and the sophistication of its mechanical computation suggest that it might represent a simplified version of more complex calculation devices that could have been used for climate management systems requiring precise astronomical timing and mathematical calculation. The underwater ruins off various coastlines around the world, submerged by post-ice age sea level rise, include architectural features that demonstrate construction capabilities and urban planning knowledge that exceeded what conventional archaeology attributes to ice age civilizations. These submerged cities might represent evidence of the advanced civilizations responsible for climate manipulation. The Yonaguni Monument off Japan shows geometric precision and architectural sophistication that suggests artificial construction rather than natural geological formation. The monument's terraced structure, right angles, and apparent stairway systems indicate construction capabilities that would have required sophisticated quarrying and engineering techniques. The global distribution of megalithic sites shows patterns that suggest coordinated construction rather than independent cultural development. The sites often demonstrate similar construction techniques, astronomical alignments, and geometric principles, despite being separated by thousands of miles and supposedly constructed by cultures with no contact with each other. This global coordination might indicate that megalithic construction represented a worldwide project designed to preserve essential technological knowledge or maintain functional components of climate management systems. The sites might serve as a distributed network of information storage and operational control centers for planetary-scale technological systems. The symbolic systems found at megalithic sites often include similar motifs and mathematical relationships, despite their geographical and temporal separation. These shared symbolic languages might represent technical notation systems designed to preserve operational instructions for climate management, technologies and forms that could survive cultural transitions. The electromagnetic anomalies detected at many megalithic sites suggest that the monuments might incorporate technologies or materials that continue to affect local electromagnetic fields. These effects might represent residual operations of ancient technological systems or indicate that the monuments were designed to interact with natural electromagnetic phenomena. The acoustic properties of many megalithic sites demonstrate sophisticated understanding of sound engineering and resonance effects. The chambers and passages in these monuments often amplify or focus sound in ways that suggest they were designed for specific acoustic purposes that might relate to operational requirements for technological systems. Modern archaeological research using advanced scanning and analysis techniques continues to reveal hidden complexities in megalithic architecture that suggest purposes beyond what surface observations indicate. Underground chambers, internal passage systems, and hidden geometric relationships might represent functional components of technological installations rather than simple architectural features. The preservation of megalithic sites through thousands of years of weathering, geological activity, and human interference suggests construction techniques and materials that exceeded normal building requirements. The monuments might have been designed for long-term preservation of essential information or operational capabilities that needed to survive across geological timescales. The echoes in ancient architecture might ultimately reveal themselves as functional components of the climate control systems that created Ice Age conditions. Rather than representing primitive attempts at monument construction, these sites might preserve sophisticated technological installations designed to monitor, calculate, and potentially control planetary climate systems. Their mathematical precision, astronomical alignments, and global coordination all suggest that they serve purposes that extend far beyond ceremonial or symbolic functions into the realm of practical technology designed to manage planetary environmental systems. As we stand at the threshold of our own technological mastery over planetary systems, the Ice Age begins to reveal itself not merely as a geological epoch to be studied, but as a mirror reflecting our own potential futures. In the frozen archives of Earth's climate history, we may be glimpsing not just the past, but a preview of choices that lie ahead for our own technological civilization. The parallels between our current moment and the hypothetical conditions that preceded the Ice Age are both striking and unsettling. We possess, for the first time in recorded human history, the technological capability to alter planetary climate systems deliberately. Our geoengineering research explores precisely the same mechanisms that could have triggered Ice Age conditions: atmospheric composition modification, solar radiation management, oceanic circulation alteration, and biological system manipulation. Modern climate models reveal that Earth's current interglacial period is inherently unstable and could be maintained indefinitely through technological intervention, or could be terminated through the same means. The stable climate conditions that have enabled human technological development throughout recorded history might themselves be artificial, maintained by systems whose origins we don't understand and whose continued operation we cannot guarantee. The moral dimensions of planetary climate control that we are only beginning to confront may have been wrestled with by our predecessors with consequences that shaped the very world we inhabit. The questions we face about international cooperation, environmental justice, technological safety, and intergenerational responsibility might echo debates that occurred in council chambers and laboratories of civilizations whose names have been erased by time. If the Ice Age was indeed artificially created, its duration, nearly 100,000 years, suggests that whoever initiated it either lost control of their climate management systems or chose to maintain Ice Age conditions far longer than originally intended. This possibility offers a sobering warning about the reversibility and controllability of planetary-scale technological interventions. The precision with which Ice Age conditions ended, establishing the stable climate patterns that have supported human civilization, might indicate that our current environmental conditions are themselves the product of successful climate management by predecessor civilizations. A Holocene epoch that enabled agriculture, permanent settlements, and technological development might represent not natural climate stability, but artificial climate optimization designed to support technological civilization. Our growing understanding of climate system complexity reveals that the stable conditions required for technological civilization exist within narrow parameters that could be easily disrupted by relatively small changes in atmospheric or oceanic systems. The maintenance of these stable conditions might require ongoing technological intervention rather than natural equilibrium, suggesting that we may have inherited responsibility for managing systems we didn't create and don't fully understand. The archaeological mysteries that continue to emerge from Ice Age and post-Ice Age context, the megalithic monuments, the preserved knowledge systems, the technological artifacts that exceed their supposed chronological capabilities, might represent not primitive attempts at civilization, but sophisticated emergency preservation systems designed to transmit essential knowledge across the dark ages that followed climate manipulation gone wrong. The mythological traditions that preserve memories of divine weather control, catastrophic floods, and technological capabilities that exceed normal human limitations might serve as more than entertainment or spiritual guidance. They might be humanity's oldest technical documentation, encoded in narrative form to survive cultural transitions and preserve essential information about climate management, technologies, and their consequences. The sudden emergence of human technological capability following Ice Age termination might reflect not independent development, but the successful transmission of preserved knowledge from predecessor civilizations. The rapid development of agriculture, astronomy, mathematics, and urban planning that characterized early human civilizations might indicate access to information systems and educational resources that exceeded what should have been available to recently nomadic populations. The global distribution of similar architectural techniques, astronomical knowledge, and symbolic systems suggests that early human civilizations possessed communication and coordination capabilities that implied either direct contact across vast distances or inheritance from common technological predecessors. The shared knowledge systems that enabled simultaneous development of complex civilizations worldwide might represent successful activation of preserved information systems. Our current climate change challenges might represent not the first time that technological civilization has faced the consequences of atmospheric modification, but rather the latest iteration of a cycle that has repeated throughout Earth's history. The warming that results from our industrial emissions might trigger feedback loops that parallel those that ended previous interglacial periods, potentially leading to renewed Ice Age conditions through natural mechanisms that our predecessors learned to control artificially. The discovery and development of climate management technologies that could prevent or reverse natural climate transitions might represent not innovation, but rediscovery of capabilities that were mastered and then lost by previous technological civilizations. Our geoengineering research might be following pathways pioneered by our predecessors, with the potential to repeat both their successes and their mistakes. The ethical frameworks we develop for governing climate management technologies will determine whether we avoid the pitfalls that may have trapped our predecessors or repeat their errors on an even larger scale. The decisions we make about international cooperation, technological safety protocols, and long-term planning will shape not just our own civilization's future, but potentially the future of all life on Earth. The preservation of human knowledge and technology through potential climate transitions has become a crucial consideration as we develop capabilities that could trigger planetary-scale environmental changes. The methods we establish for maintaining essential knowledge and technological capabilities through potential dark ages will determine whether future civilizations benefit from our achievements or must rediscover them independently. The responsibility that comes with planetary-scale technological capability extends beyond immediate human interests to encompass all species and ecosystems that share Earth, as well as potential future civilizations that will inherit the consequences of our choices. The climate management decisions we make today might influence planetary conditions for geological timescales, creating legacies that persist far beyond our own civilization's lifespan. The Ice Age, viewed as a mirror of our own potential futures, suggests that technological mastery over planetary systems represents both humanity's greatest opportunity and its most dangerous capability. The frozen millennia might serve as both cautionary tale and instruction manual, encoding lessons about the ultimate consequences of wielding the power to reshape the fundamental conditions of planetary life. As we stand before the same crossroads that may have confronted our predecessors, the choices we make about climate management technologies will determine whether we achieve stable, sustainable control over planetary, environmental systems or repeat the cycle of technological ambition followed by Ice Age consequences. The mirror of the past reflects not just what was, but what could be again, and challenges us to prove worthy of the power we are rapidly acquiring to control the very breath and heartbeat of our world. In the end, the Ice Age may reveal itself as neither natural disaster nor technological catastrophe, but as a test of planetary-scale examination of whether technological civilizations can develop the wisdom to match their power, the cooperation to manage global systems responsibly, and the foresight to create stable conditions that support life and consciousness throughout cosmic timescales. The mirror shows us not just our past, but the reflection of our species' ultimate potential and responsibility as stewards of planetary evolution itself. If this journey through time and possibility has captured your imagination, consider subscribing to explore more mysteries that lie hidden in the intersection of ancient wisdom and modern science. The past holds keys to futures we are only beginning to imagine, and every frozen clue brings us closer to understanding our true place in the cosmic story of intelligence, technology, and the endless dance between civilization and the natural world.